Can you fill the screen?
Yeah, it's not full screen yet.
We welcome Senator Tim Richards, Vice Chair of AEN from Hawaii Island.
Originally, I was planning to have a Zoom meeting, but this morning I realized the importance of this meeting, so I decided to come in person instead.
Appreciate you coming, Professor.
Works better. Okay, looks like this is well,
Yeah, maybe we move forward with this for now, and we'll have staff work on trying to improve it.
Yeah.
we'll just move on. Yeah.
Yeah.
Okay, let's get back to the first one, the first slide.
And if you need to move closer, Professor, you could go up there.
Yeah, probably it's better.
Yeah. Go up the mic on the.
Right. Can you move to the first slide?
First slide. The first slide. Are you going with the first slide?
Oh, okay. All right. So the title of my talk is Impact and the Future Projections of Climate Change on Hurricane and the Drought in Hawaii. I'm Paul-Shin Chu, affiliated with the Department of Atmospheric Sciences and the Hawaii State Climate Office in the School of Ocean and Earth Science and Technology. Chip is my boss. Okay. And also, at University of Hawaii. Okay. So I'm very glad to be here to have the chance to talk about these important areas for Hawaii. Next one. Oh, well, let's first be clear about the nomenclature of tropical cyclone. So when we say tropical cyclone, it means that we have a severe storm that formed in the tropical ocean. And basically, there are three types of tropical cyclone. Starting from the weakest one, we call the tropical depression, and then to tropical storm. And at this stage, we give storm a name. And then the hurricanes. Okay, hurricane is the strongest type of tropical cyclone. And for hurricane, the wind speed is at least 74 miles per hour. Okay. And the hurricanes also can be classified into five categories from 1 to 5, with 5 being the strongest one. Okay. And sometimes you may have heard people talking about a major hurricane, which means a category 3 to category 5 hurricane. Okay. So the wind speed is at least 111 miles per hour. So that's very powerful wind speed. Okay. And as we know, when we talk about a hurricane, we always think about something like a destructive wind, torrential rainfall, flooding, and the storm surge. Okay. And in Hawaii, the interactions of hurricanes with mountain, because we have high mountains here, so this enhance this high intensity rainfall, and also trigger flash flood, and also this landslide. Okay, so there's another problem in Hawaii with hurricanes. Okay. Next slide. Here I just give some examples of hurricanes that inflict major damage to Hawaii and also are very close to Hawaii. So starting with the Hurricane Eva in 1982, November, very late time of the year for hurricane. So caused major damage to Kauai. And this storm occurred when the 1982-83 El Nino reaches almost its maximum intensity. Then 10 years later, we have this Hurricane AEN-EEP, which caused damage to Kauai again. And damage back then was 3.1 billion, but that was 1992 values. And nowadays, it's almost like $6 billion. Okay, damage. That's a lot. And took Kauai almost 10 years to recover from Hurricane AEN-EEP. Then more recently, in 2015, that it was also another very strong El Nino year, and we have a lot of hurricanes. And actually, at one time, Hawaii was sandwiched by 3 Category 4 hurricanes. So that was very unusual. Okay. And in 2018, Hurricane Lan, which is a Category 5 hurricane, also caused a lot of problems for Hawaii. Okay. And also that bring not only heavy rainfall, but also fire. Okay. Fire. And then more recently, we have a Hurricane Douglas in 2020, which was very close to Oahu, only about 30 miles. Okay, next one. So this picture shows the aftermath of Hurricane AEN-EEP in 1992 on Kauai to the left. And to the right, you can see you have 3 Category 4 hurricanes in the Central Pacific and the Eastern Pacific. Hurricane Kilo, Hurricane Ignacio, and the Hurricane Jimena. Okay, right. So that was those 3 hurricanes were all Category 4 hurricanes. So that was very scary picture when we saw this one. Okay. Next. And on the left shows the best track position of Hurricane Lan, which was on during August 15 to 28, 2018. Okay, right. So we can see Hurricane Lan was a Category 5 hurricane, and on August 21st, and was heading toward Oahu. The problem with Hurricane Lan was it was very strong. It was a Category 5 hurricane with more than 160 miles per hour wind, and also its motion was very slow. Okay, right. And it was very close to Oahu, so the National Weather Service has issued consecutive warning for almost 3 days. So it caused a lot of anxiety and scare for Hawaii. Okay, right. And it was one time it was forecast just toward Oahu. Okay, and fortunately at the last minute it turned westward and moved away from Oahu. Okay, and the picture on the right shows a 6-day rainfall during Hurricane Lan, so that all major 4 islands received lots of rainfall. Okay, particularly the Big Island. Okay, received more than I think something like 58 inches of rainfall in 6 days. Okay, right. And then moved to last year, 2023. We have a tropical storm Calvin, which also dumped a lot of rainfall on the Big Island. And then also we have a Hurricane Dora, which passed just to the south of Maui, okay, on in early August, okay, and with a very strong subtropical high pressure system to the north, so this generated very strong pressure gradient, and then because of the mountain, so it produced a very strong downslope wind up to almost 70 miles per hour, okay, and it caused a problem for particularly Lahaina, okay, right. So we all know that was the big inferno and caused more than 100 people, dead from this inferno. Okay. Okay, next one. And in the past, I talked about the hurricanes were very active during some El Nino years. So here, the top one shows the storm tracks during 6 El Nino years over the central North Pacific. So here, tropical cyclone, I mean just a tropical storm and a hurricane. Okay. So we see that central North Pacific is defined a region according to the National Weather Service to the north of equator between dateline and 140 west. Okay. And the bottom one shows hurricane tracks during La Nina. So during 4 La Nina events, there were only 7 tropical cyclones. So in other words, if you look at the average, 5.5 tropical cyclones were observed during El Nino year versus only 1.75 during La Nina. So the ratio is 3-to-1. So in other words, during El Nino years, you expect to see more hurricanes coming into the central North Pacific. Okay. Whereas you have fewer hurricanes during La Nina years. Next one. Even if previous one, we looked at this relatively large region over the central North Pacific. But if you just narrow down to a smaller area just near Hawaii, so here I draw a radius of circle 250 nautical miles from Honolulu, okay, which is relatively small compared to the central North Pacific. But you can also see some difference that in terms of the annual mean frequency of tropical cyclone during El Nino years is higher than that during the non-El Nino years. So you can say with some statistical confidence that indeed there's even though we look at a smaller region just near Hawaii, in the vicinity of Hawaii, but we can also see there are more hurricanes during El Nino years compared to La Nina years. Okay. Okay, next one. Okay, so I co-authored a book with Dr. Murakami. He works at the NOAA Geophysical Fluid Dynamics Laboratory in New Jersey. So the book is titled Climate Variability and Tropical Cyclone Activity. So in this book, we consider how climate variability influence tropical cyclone activity, like how the formation location would be shifted, how the frequency of incidents will be changed, and how the storm track will be different. Okay, right? And also rainfall and landfall location intensity and so on. Okay, right? So here in this book, we look at the Pacific, not only the Western North Pacific, but also Eastern North Pacific, Central North Pacific, and South Pacific, and also North Atlantic. Okay, so climate variability would mean something like El Nino, La Nina, Median Julian oscillation, and Pacific decadal oscillation, and so on. And there are 7 chapters in this book, but relevant to this meeting, I think the most important part and most interesting part would be the last chapter. Okay, so last chapter focuses on future tropical cyclone changes, okay, in relation to the increased concentration of greenhouse gases. Okay. Next one. So this figure is drawn from the book. Okay. So what is shown here is a tropical storm change based on the CMF5 models in the future. Okay. Right. Relative to the present-day climate. Okay, right. So if you look at the middle one, which is the Northeast Pacific, okay, which includes Hawaii, And this shows that the relative change, okay, from the present day climate. Okay, right? So you can see that overall the tropical storm frequency doesn't change. That's the first one, indicated by 1. Okay, but there 2 means the annual number of Category 4 and 5 hurricanes. So you can see there's an increase in Category 4 and 5 hurricane in the future. Okay, right? 3 means that storm intensity, right? So storm intensity also becomes stronger. And the 4 is storm rainfall. Storm rainfall also get increased by almost 20%. Okay, so this means that in the future, that the overall number of tropical cyclone over the eastern North Pacific doesn't change too much. But the Category 4 and 5 hurricane will become more frequent, okay? And also storm intensity becomes stronger. And more important, the storm rainfall would be almost 20% higher than the present day climate. So this is the conclusion from this study, okay? Next one. Okay, so there's another study which is aimed toward Hawaii, okay? Right. So this is based on the high-resolution atmospheric general circulation models. Okay. So on the left, upper left corner shows everything from the observations. Okay. In terms of annual mean storm number. Okay. Right. So you can see it's pretty high in the Eastern Pacific. Right. In the tropical region, it is depicted in red. Okay. Right. In Hawaii, the value is relatively low, maybe between something like a one or 2 tropical cyclone per year. Okay, right? And on the right, upper right corner shows the simulated present-day tropical cyclone frequency. Okay, and you can see that the model shows reasonably well. Okay, in terms of showing this. Location of the maxima and also the annual mean numbers, okay. But the model also is not perfect. Model also tends to underestimate annual mean tropical cyclone frequency to the west of 120 west, okay. So this is a simulation from the present day, and the lower left is the simulation for the future, okay. Right. Future. That basically you can see there's an east-west contrast, okay, which is more clear, okay, right. And the lower right panel shows the difference between the future minus the present-day climate in terms of tropical cyclone number, and we can see there's a very large decrease, okay, which is shown in blue in the tropical region, Eastern Pacific to the Central Pacific. But in Hawaii, that you can see there's a very large increase, okay, like which is shown in red color, right? Because the annual mean number of tropical cyclone from observation is very low in Hawaii region. It's about maybe 1 to 2 per year, and this increase is also about 1, okay. So that so this means that this is really alarming. In the future, we expect to see more tropical cyclone in Hawaii area. And the panel to the right, far right, is the projected change in stream flow, because tropical cyclone motion is governed by stream flow, okay, in the atmosphere. Okay, right. So it shows that in the future we have increased easterly stream flow, so which would lead to enhanced westward propagation of tropical cyclones, as you saw from this panel in lower right. Okay. Okay. Next one. And here also, I'd like to say something about this timing of change of intense tropical cyclone. So here, intense tropical cyclone means Category 4 and Category 5. So they are the most intense hurricanes. Okay. And if you look the upper left corner, the solid line, okay, up and down, shows the climatological value of intense tropical cyclone number. So for example, in the northern hemisphere, the peak value of intense tropical cyclone occurs in September and October. And in the southern hemisphere, it occurs in March, okay, right? The different time of the year. So these intense tropical cyclones, usually its occurrence is different from other high impact weather system like a summer monsoon rainfall or local thunderstorm. Usually they occur in summertime, okay? So one is in autumn, one is in summer, okay, right? And the bar shows the trend, okay, for intense tropical cyclone month by month, okay? So if you look at the northern hemisphere, the trend is all positive. That's in colored in red, okay, right? From May, June, July, August, right? Okay. Not in the northern hemisphere. And in the southern hemisphere, it shows a positive trend in December, January, and February, okay, right? So this means that there's evidence of increased intense tropical cyclone occurrence in the early season, right? Okay, because usually they occur in the autumn, but now the trend becomes positive in summertime, okay, right? So, and so this is not only in the northern hemisphere, but in the southern hemisphere, also you see that positive trend in December, January, and February. This is the southern hemisphere summer, okay, right? So they tend to occur earlier. And also the trend becomes negative in September and then November in northern hemisphere, and in March and April in southern hemisphere. So this means there's a decreased intense tropical cyclone in the late season. And the bottom figure shows the trend in terms of the interseasonal difference, okay, in intense tropical cyclone. So in other words, it is summer intense tropical cyclone number minus the autumn intense tropical cyclone number. Then you look at the trend, okay. It shows that the trend is all positive in the western North Pacific, in the eastern North Pacific close to Mexico, and also Gulf of Mexico, and also in the Caribbean area, also some part in southeast US along the Florida coast, and also in South Pacific and in South Indian Ocean, okay. So in other words, shift toward early onset is not just a local phenomena, it is kind of like a global phenomena. Okay.
Professor Chu, if you could wrap it up.
Okay.
Please,
yeah.
thank you.
Right, okay. Right, next one, please. So there's another way to look at this information that I plotted that the time series of the median days of intense tropical cyclone occurrence, okay. For the northern hemisphere, southern hemisphere, the time goes downward, okay, right? For the northern hemisphere, from August through November and so on, okay. So we can also see there's this increasing trend for both northern hemisphere and southern hemisphere. So in other words, the intense tropical cyclone, have been arriving earlier, okay, almost like 3 to 4 days per each passing decade since 1981, okay. But this signal is also clear in the southern hemisphere. Okay, next one. So this one probably is hard for you to see, okay. But now let's shift the gear to drought, okay, right. So I started with this diagram, this flow chart at the top shows natural climate variability. So we can think this is something like El Nino or Pacific Decadal Oscillation and so on, okay, right. So that if we have El Nino, then we have this change in precipitation in terms of reduced rainfall, amount, timing, and also the seasonal difference, okay, right? And then if we have a reduced rainfall, then this leads to the reduced infiltration, okay, and so on. And parallel to this one, if you have El Nino, then you also expect to have a warmer temperature, and you have less cloud, okay, right? So you have more sunshine, okay, right? So this would increase the evapotranspiration. So taking these two together, then this leads to the soil moisture deficiency, and then you have a reduced stream flow and also so on. Okay, right. Then you have something like called a socio-economic drought, meteorological drought, agricultural drought, and hydrological drought. Okay, so drought. They have several different types of drought. Okay, next one. And in the past, I studied Hawaii rainfall variations associated with El Nino, La Nina, and Pacific Decadal Oscillation. Okay, so for example, this shows the Hawaii rainfall index is a composite during El Nino event, during La Nina event. Okay, because El Nino lasts about 1 year. Okay, so this is a 1 year cycle. That shows that this shows that the rainfall was low starting from November. Okay, which is shown in this black bar, and runs through April of the next year. So in other words, when El Nino starts, we have a 6 months of drought, with the largest negative deficiency occurs in January and February. So since this is El Nino year, so this is January, and next month we expect to have a very low rainfall. Okay, and for La Nina, which is just the opposite. So those 6 months, you have abundance of rainfall. So this is our wet season, okay, right? And the one at the bottom shows, if you consider the Pacific Decadal Oscillation, okay, and also with El Nino, okay. So if you have a El Nino which is embedded within the positive phase of the Pacific Decadal Oscillation, then you can see that rainfall was very low, okay. The patterns are very similar to the top one, just with El Nino. But the difference is that the magnitude of anomalies has doubled. So the top one, the largest negative anomaly was -0.4, now becomes -0.8, okay, right? So the magnitude becomes intensified, okay, right? And El Nino also has bearing on wildfire, okay, in Hawaii. So the figure on the right shows total acres burned by wildfires during El Nino cycle. Okay, so we can for Oahu, so we can see in spring and summer, in the year following El Nino, there's a large acres burned by wildfires. Okay, it's very clear. Okay, right. So I think because El Nino will have a very dry weather, very dry climate. Okay, right. So we have a dried out vegetations. Okay, and we have a very low soil moisture, okay, right? So it promotes this wildfire occurrence in the following year, but not during El Nino year, in the following spring and the summer. Okay, right? And also the bottom figure table shows some predictions. So we try to predict summer total acre burn from the previous winter climate data, and also with a nonlinear regression model, okay, for 4 different islands, okay. So that here we call the event, means that the total acre burn is above the 75 percentile of its distribution. Then we call this is an event, okay. So the model correctly classified the event 5 out of 5 times for Kauai, and 5 out of 6 times for Oahu, and 3 out of 6 times for Maui and the Big Island. Okay, so it looks like there's some some skills from this fire prediction. Okay, from long range. Okay. Okay, next one. Yeah, almost done. Okay. Yeah. Okay, maybe we can skip this one. Okay. Yeah. Okay, so this shows the percent areas, okay, of drought during the last 20 years in Hawaii. So the drought is expressed in terms of some information like you have different degree of drought, okay, right? From the smallest yellow to orange to red to the dark red, okay, right? So we can see that during the last 20 years, the drought was pretty severe from 2009 to 2014 in the middle of this figure, okay? And also that it was pretty severe, okay, right? And we also looked at the drought per decade since 1920s, okay? So this is every decade shows the drought conditions expressed in the SPI, Standardized Precipitation Index. So during the first 5 decades, there was hardly any sign of drought, okay? And the negative values start to show since 1970s and becomes more severe during the last 3 decades, okay? And particularly during the last decade, and a major part of Kauai, of Big Island, East Maui, and some part of Oahu, really had this very severe drought. Okay. Okay, next one. Okay, so here talk about the future rainfall projection to the future. Okay, right. So based on the statistical downscaling, it shows on the windward region during the wet season, you have more rainfall, and on the leeward side, you have a less rainfall, okay, in the future. And from dynamical downscaling also shows more or less similar kind of conclusions, okay, right? So that the wet area becomes wetter, dry area becomes drier, okay. Right. Okay, the next one, that should be my last one, okay, right. So that here, try to summarize everything. So we have a major climate mode which modulate hurricane activity, okay, in Hawaii. And when we have El Nino, then we expect to see more hurricanes. And also, for 2 degrees C warming, that we see we have a higher number of intense hurricane, category 4 and 5, over eastern and central North Pacific in the future. Okay, and the hurricane rainfall also is expected to be more in the future. Okay, right, and also there's a substantial increase in TC frequency near Hawaii in the future. Okay, and we have intense TC which occurred earlier than before, and it may cause some kind of compound area. Okay. And in terms of rainfall, in terms of, no, this is wildfire. So wildfire, we expect to see more wildfires in the spring and the summer following El Nino event, okay, right? And long-lead fire prediction is promising, okay, right? And the drought becomes more widespread and intense in the most recent decade, okay, particularly for the last 20 years, okay, right? Particularly eastern Maui and also the island of Hawaii, okay. And prediction of future rainfall using high resolution, okay, that's also possible. Because the previous study based on CMAP 3 and CMAP 5, that was more than 10 years ago. So the model also have developed more rapidly during the last 10 years. And now we have some high resolution global model. I think that can provide a better projection for the future. Okay, I think.
Thank you very much, Professor Chu.
Yeah. Maybe I talked too long. Okay, I'm sorry.
Thank you very much. Our next speaker will be Dr. Charles Chip Fletcher, the interim SOAS Dean. He is the former chairperson of the Honolulu Climate Change Commission. He received the EPA's Environmental Achievement Award in Climate Change Science in 2011. And with his students, he has published 3 textbooks and more than 100 peer-reviewed articles.
Thank you, Senator.
And we also have your PowerPoints on our screens here too, so
Okay.
we have a good view of them. And if we're looking here instead of there, that's why.
Thank you. Great. The information just arrived that last year, 2023, was the hottest year on record. We had a number of climate indicators this past year bringing this information to us. If I can get my slides to move. One of the characteristics of this past summer in the Northern Hemisphere was a series of heat domes that form, and these are the result of a jet stream in the Northern Hemisphere that has become unstable because of the rapid heating of the Arctic, so that the temperature difference between the tropics and the Arctic is becoming less and less, and therefore heat exchange is slowing. And the jet stream is slowing. The jet stream has developed large meanders, and when there's a meander to the north, it pulls up tropical air, which sits over the continental areas sometimes for a few weeks, creating enormous heat domes that may lead to a lot of medical issues and even fatalities. 2023, if looked at from the point of view of June, July, and August, in other words, the summer of 2023 is plotted here against all of the summer times since 1940. You can see it sits way outside the long-term trend of the summers of previous years. It was an extraordinary year in that respect. This red line shows 2023 daily surface temperature on the planet. All of the gray lines and blue lines below that are previous years. And around June, the red line completely departed from the background of these earlier years and broke out of the envelope of variability, and we see extremely hot day-to-day temperatures taking place, unrelenting over the course of the entire last 6 months of this year. This graph shows sea surface temperature. Again, beginning over on the left, we have January running through the 12 months to December. These gray lines all represent different years, going back 40 years. 2022 is shown in the orange, and 2023, again, sat above the entire envelope of years, going back several decades. It was an extraordinarily hot year. And the extent of global sea ice, both in the Arctic and Antarctic areas, hit dramatic lows. This red line is 2023. You can see that in terms of millions of square kilometers, global sea ice from June through November was far below any previous year. Scientists are speculating that we are now seeing an acceleration in the rate of global warming. Every month from June to December of this past year was the hottest ever recorded globally. 2023 is the warmest year ever measured. It almost reached 1.5 degrees Celsius, which is a UN benchmark I'll talk about in a second. And this is just from the European Union data set. We still have to hear from NOAA and NASA. And November 17th and 18th of 2023 were the first days on record to have a global average surface temperature above 2 degrees Celsius. We all are aware of the United Nations Framework Convention on Climate Change, which is the entity that holds annual conferences. Their conference in 2015 in Paris led to all of the world's nations agreeing to cut their greenhouse gas emissions sufficient to stop warming before reaching 2 degrees Celsius. The small island nations of the world walked out, refusing to sign that, calling it a death warrant. And so additional wording was put in place to pursue efforts to end warming before 1.5 degrees Celsius. This temperature threshold, 1.5, became the new global target for stopping global warming. And it's appropriate to ask, how are we doing? And so on the bottom axis, we have time. On the vertical axis, we have carbon dioxide emissions. And in black, we see historic emissions peaking in 2019 and then decreasing during the recession related to the COVID pandemic. CO2 emissions fell about 5.5% during 2020. And then with the release of stimulus funding from the world's nations to get the economy up and running again, we saw a new record of CO2 emissions. CO2 emissions globally rose over 6% in 2021. They rose another 1.2% above that in 2022. And in 2023, they rose additionally 1.1% above the previous year. The pathway to stopping warming at 1.5 degrees means that we must reach net zero before 2050, and it's shown in the green line. If you take all the promises of the world's nations under the 2015 Paris Agreement, It puts us on a track to stop warming at 2.3 degrees Celsius. But there's a difference between promises and actual policies. The world's nations' actual policies and investments in fossil fuel energy show that we're on track to warm nearly 3 degrees Celsius. This represents a gap between promises and actual investments. And every year, the United Nations comes out with what's known as the GAP report, telling us in detail about this problem. The GAP report for 2023 came out in early December, and it tells us that greenhouse gas emissions need to be cut by 28% in the next 5.5 years to keep within 2 degrees Celsius. And based on current commitments, emissions will only be cut 2%. Net zero pledges of the world's nations cover about 80% of emissions, but most of them, when analyzed, are hollow and lack implementing mechanisms. Limiting warming to 1.5 degrees Celsius would require global emissions reductions of 9% per year. And if you'll recall, even during the COVID pandemic, we were only able to cut emissions 5.4%. Globally, governments still plan to produce more than double the amount of fossil fuels in 2030 than would be consistent with stopping warming at 2 degrees Celsius. This graph came out from the Rhodium Group. It shows that emissions are projected to peak potentially this year or next year, and then go into a long plateau, a gentle slide, only being reduced a few percent by 2050 and perhaps rising again by the end of the century. These projections put us on a pathway of about 3 degrees Celsius. The good news is that after 200 years of fossil fuel expansion, we are at a turning point in the global energy system. Global renewable energy grew by 50% last year in 2023. This is the fastest in 2 decades. By 2028, renewable energy will account for over 42% of global electricity generation. In 2020, 1 in 25 cars sold were electric, and last year, 1 in 5 cars sold were electric. Global energy demand growth will now almost entirely be met by renewables, according to the International Energy Agency. And economic growth no longer requires rising emissions. This is a remarkable accomplishment, but ambition needs to accelerate. Oil and gas production continue to increase, and we are headed for a long plateau of continued emissions. Globally and here in Hawaii, we are engaged in a sustainability transition. We are focused on cutting carbon emissions because that is what is needed immediately and over the long term in order to stop global warming. This is called mitigation. And because there are climate hazards that have already been triggered by the warming we have created, we must engage in adaptation. Doing this through a social equity lens, that is putting people first, especially underrepresented and underserved communities, and engaging in mitigation and adaptation simultaneously, is called climate resilient development. This term is proposed by the Intergovernmental Panel on Climate Change in their assessment report number 6. We cannot focus just on mitigation and just on adaptation. We must do all of the above, and we must take care of our underserved communities first. Doing this involves recognizing and investing in public health, investing in affordable housing, investing in education, investing in water resource management, stopping our overconsumption, tracking disease, which is growing in prevalence, stopping biodiversity loss, and stopping economic trade that is not consistent with ecological preservation and stopping pollution. It's important that we not get carbon tunnel vision. Yes, we must stop our emissions, but we have all these other jobs to do at the same time. This is what a true sustainability transition would entail. Regarding sea level rise, the recent report from the IPCC said that sea level is committed to rise for centuries to millennia. This is due to continuing deep ocean warming and ice sheet melt, and will remain elevated for thousands of years. They have high confidence in this statement. In other words, sea level rise is an unstoppable reality. It is accelerating, and our laws and policies must keep up. How high will sea level rise? From this, there is information from a federal task force that provided sea level planning scenarios for every tide gauge in the US. This is the set of planning scenarios for the Honolulu tide gauge. These lowest two scenarios, called the low and intermediate low scenarios, would require that sea level rise slow down. So they are no longer viable. The intermediate scenario would have sea level rising 4 feet by 2100, and the intermediate high scenario about 6 feet by the end of the century. These scenarios give guidelines for every decade all the way through 2150, so that we can plan the elevation of building renovations, new roads, moving roads, all sorts of changes to our coastal communities so that we can avoid flooding. Which of these scenarios do we pick? That depends on the sensitivity of the project. If you were to build a nuclear power plant in the coastal zone, you'd want to pick the high scenario because you can't afford to get it wrong. That's an example. Our group at the university has been modeling many of the impacts related to sea level rise. This is the community of Eva Beach, which shows the annual high wave run-up under 1 foot of sea level rise, which is projected to occur around mid-century. At this scale, it only shows the front of the beachfront houses getting hit by wave run-up. Here we are with 2 to 3 feet of sea level rise. Every summer then, this would be the high surf. This is not a hurricane. This is our typical swell where you grab your surfboard and go out and catch the swell. You can see the run-up by 2075 punches in a block or more through Eva Beach. And we are projected to reach 4 feet of sea level rise. So by the end of the century, we're looking at the entire Eva Beach community every summer being inundated by waves. We also have coastal erosion. These green lines represent where our models are applied every 66 feet along the shore or 20 meters. Here is the erosion model line for 1 foot of sea level rise, 2, 3, and this would be by the end of the century. We see hundreds of homes and miles of roadway threatened by erosion under 4 feet of sea level rise. We also know that as sea level rises, the water table under our buildings and homes and roads will rise. So follow the red line, sea level rises, and of course we get wave and tidal flooding over the shoreline, but this boundary between freshwater and saltwater under the ground also rises, pushing the water table up, leading to groundwater inundation. We already see this happening at high tide, and this is our scientist, Dr. Shelley Habel, measuring the salinity and finding near ocean water salinity in the foundation of one of the hotels in Waikiki. We also know that there is World War II pollution floating on the water table, especially in the Ivalai area. So sea level rise will bring polluted groundwater to the surface, not only this World War II pollution, but all of the cesspools and leaky underground storage tanks, as well as the main force lines for sewage delivery. We already see at high tide flooding coming out of our gravity-fed storm drain system. This means that at high tide, the very foundation of our drainage system, which is gravity, is no longer in play. Gravity drainage no longer works in Waikiki, in huge parts of Kaka'ako, and in many parts of our coastal communities. Miami Beach has recognized this, and they have already started putting pumped drainage in place, where they rescape a block so that when it rains, the water flows towards a pump. That water is partially cleaned and then pumped into Biscayne Bay. And of course, when it rains, we have what's known as compound flooding. And here we are in the summertime. During the summertime, our highest high tide of the day occurs at the end of the day when everybody's trying to leave Waikiki to hit the H1 and go home. If it rains then, you have high tide, the water table is high, the storm drains are filled with salt water, there's no place for the rain to go, and you break up families for hours. Often they don't get together again until midnight or so. So this is an example of a rain that, a Kona storm that occurred December 5th in 2021. You can see Waikiki is under about 1.5 feet of water. And the only reason those storefronts aren't flooded is because they've been recently redesigned under FEMA guidelines so that they are raised slightly above a potential flood layer. And with that, I will end, and thank you very much.
Question, Dr. Fletcher.
Yes, sir.
Any bright spots in the global effort? A lot of bad news there, but against climate change?
Yeah, the bright spots are that all the key factors are aware of the problem. Really, it boils down to the fact that if we need trillions of dollars to invest in clean energy. But if you're an investor, you still make more return through oil and gas. We need clean energy to give the same return that oil and gas does. A lot of great things have been accomplished. We no longer need to increase emissions in order to engage in development. We have lots of renewable forms of development, but it can't all ride on the backs of the government. We need the governments of the world to be more honest about their promises, and we need the investment community, where most of the money actually resides, the investors to get more return for their investment, or for them to be more angelic in their investment decisions.
Thank you. Members, any other questions?
Just a brief. Yeah, that was a great presentation. I felt like it really kind of summed up the gravity, especially with the news this past year. And I just appreciate it because you don't see it mentioned very often. The points you had on that circle of sustainability that drew in all the other aspects of it, mentioning pollution and overconsumption and things that have maybe been sidelined. The conversations have been sidelined for a number of years while we just focus on emissions mitigation. And
Yeah.
I think those things have ancillary benefits. When you reduce solid waste, you're saving space in the landfill, but you're also tackling a consumption issue.
Yeah, a resilient community is one that pulls together when they're hit by an extreme weather event. And so affordable housing, education for all, childcare, these create a more coherent community. And so I see all of those actions, which are top of mind on today's headlines, as climate resilient actions. They're all important.
Yeah. Thank you so much.
Thank you.
Our next speaker is John Prevender. Is it Prevender? Revender. Okay, thank you. He is the warning coordinator meteorologist at the Central Pacific Hurricane Center. He has been in that position since August of 2017. He's been a meteorologist since 1999. He got his Bachelor of Science degree from University of Michigan. John, go blue. Hello, congrats to your Wolverines. Winning the national championship. My wife graduated in '69 from UM, and my eardrums are still recovering from all the screaming that was going on. I wasn't even in the same room, but anyway, congrats. So, okay.
Thanks, Senator. Yeah, I think I'm the token Michigan graduate for several people in Hawaii, so I got lots of congratulations texts on Monday. Thanks for having me here, and hopefully we'll have some going after Chip is always very sobering to see the state of things. And as a meteorologist with the Central Pacific Hurricane Center, I'll take this from more of a hurricane aspect for what we do here. To set the stage for what we're talking about for tropical cyclones, this is looking back several decades, past tracks of tropical depressions in green, tropical storms in yellow, hurricanes in red, and major hurricanes in purple. And it's a messy plot. And for those in the back, the key message is the lots of clusters in the far eastern Pacific, not so much in the central Pacific. For reference, I'll put a couple things on here. One, Hawaii circled here in the oval for reference of where we are on the map. And then I'll throw another line on here. This is 140 degrees west longitude, which really doesn't matter for anybody except my office, because east of this line, the National Hurricane Center in Miami handles the forecast, and west of this line is our area in the Central Pacific Hurricane Center. And when I talk about the Central Pacific, it's this area that I'll reference between 140 west and the international date line. For when I talk about an average year for us, we have about 4 to 5 tropical cyclones in an average year. Pao-Shin had mentioned the averages during the El Nino years when it's busy and the La Nina years when it's quiet, less active. Overall, it's about 4 to 5, 4.5 or so. And hopefully it stands out from this map. In the East Pacific, there's a lot more activity. It tapers off as it gets closer to the state, in part between cooler ocean temperatures near us and stronger wind shear over the islands. There are a lot of tracks south of us, going east to west south of us, but you'll all see some standouts there, recurving and passing near us. And we'll take a zoom into the islands here. These are all the hurricanes that have passed within 80 miles of Hawaii since 1950. Noted on here are some of the more impactful ones. We talked about several of these already. AEN-EEP was our first billion-dollar disaster. We have since had our second last year with Lahaina. 26 fatalities all told. I'd break down some of those. Some were at sea, some due to high surf, others flying debris, house collapse, electrocution. There's been a variety of causes for the hurricane-related, tropical cyclone-related fatalities. Some of these actually aren't from impactful landfalling storms. For example, Lane didn't make landfall. We had one drowning fatality of a hiker trying to cross a stream. In 2016, we had 2 drowning fatalities due to high surf from Tropical Storm Celia, which was still in the eastern Pacific. So we can have hazards far away from tropical cyclones. And the map on the left shows the hurricanes near us. And if I step forward here, add the tropical storms and then tropical depressions as well. And we have a fair number of tropical cyclones passing near us. The tropical depressions, usually as remnants, bringing a lot of heavy rainfall, not the wind associated with them, but still damaging impacts from the rain. And an average year for us is 4 to 5, and I'll give you a flashback to 2015. This is a record-setting year of 16 tropical cyclones that year. An average is 4 to 5. It blew those out of the water. When you talk to meteorologists, if you're unfortunate enough to have friends that are meteorologists, you know that we are a strange sort that remember weather events to a crazy degree. What dates? March 9th, 2012, the record-setting hail, everything like that. 2015 is a blur to me. It was so busy, it all blends together. This composite is a satellite image from every day. Our hydrologist, Kevin Kodama, put this together. We are being a small target in a big ocean. We've only had a handful of direct impacts, and that's just luck so far. We had Eva in 82, AEN-EEP in 92. Before that, it had been DOT in 1959, as far as an impactful hurricane before that. So it's rare, but when it does happen, the impacts can be catastrophic. Now, looking at the 2015 year, as was mentioned, this was a strong El Nino year. This is the map on the left is the whole Pacific, North America on the right, Australia in the lower left. Hawaii circled in blue there, so you can see a reference. And yellows to orange to red colors are above normal ocean temperatures across the whole Pacific. We define El Nino right along the equator. We're in El Nino right now. It's not the same type of event as this. Temperatures near Hawaii and to the east of the state are cooler than normal. We didn't have as active of a year as we were expecting this past year. We had 4 tropical cyclones during this past hurricane season. If the ocean temperatures east of the state were a little warmer than they were before, we might have had 2 more. 2 of them weakened right about 130 degrees west, didn't move into the basin. If it was an event like this, we could have been above normal. But what I want to mention with this, above normal ocean temperatures average 2.5 degrees above normal. And we ended up with a very busy hurricane season. The image on the right is a composite wind field of, in orange, tropical storm force winds, and in red, hurricane force winds. Hurricanes passing north of the state, north of 30 degrees north. 2015 was a Transpac year, and talking to some of the sailors around the harbor, delivering boats back to California, they said they've never seen water temperatures that warm going that far north in the decades they'd been sailing around here. And we were just lucky where the placement was. If that cluster of tracks was shifted 10 degrees west, we would have had 4 hurricane impacts across the state. It just so happened that it set up far enough east. Like I said, we were very lucky with that season. So what does that mean going forward? I grabbed we'll reference a couple papers here just for a way to better visualize some of the impacts. This one looks at 3 decades worth of hurricane tracks and how they've changed with time. Already have seen a northward trend in the northern hemisphere, southward trend in the southern hemisphere. So all those tracks passing south of the state would be at a little higher latitude. So maybe instead of a Hector in 2018 passing well south of the state, you end up with Calvin passing south of the Big Island, bringing us some rainfall. Or, for example, Douglas passing north of us. This other model simulation looks at future projections. And 2 components here. Most of our activity in the Central Pacific comes from the Eastern Pacific Basin. So where those form in the East Pacific, it looks like that Genesis area where they develop is shifted northward, putting us more in the crosshairs as they move westward. And then also the environment around Hawaii, what we normally rely on to cause tropical cyclones to weaken on average. Cooler ocean temperatures, stronger wind shear, drier air. Those decreasing, not as unfavorable for hurricanes, causing them to weaken. So increasing the threat from both of those. But one thing I want to emphasize is that it's not necessarily a future problem. This is something that we have to look at right now. And this chart it covers hurricane season. It's the number of days with an active tropical cyclone, red hurricane, yellow tropical storm, green tropical depression, showing the peak in August into September. And we've highlighted some of the more impactful hurricanes that we have on here. We haven't updated this with the data from 2023 yet, but Dora passing south of the state on August 8th was the same day Isel made landfall on the Big Island in 2014. So that's where that falls in the chart. One thing I want to point out about this is that it's not a normal distribution up and down. It's a little longer onto the later side in the year. During El Nino years, we tend to have more active hurricane seasons. We also tend to have longer hurricane seasons, in part because of warmer ocean waters. So as ocean waters get warmer, we can have activity continue longer into the year. And that's one thing that we're worried about as temperatures rise globally. A longer window for impact, pushing our chances for some sort of direct impact throughout hurricane season. Now, Senator had asked me to talk a little bit about the Saffir-Simpson scale as well to give an idea. We talk about the different categories for hurricane. The these are some examples from the Central Pacific Basin. The Saffir-Simpson scale might be a little dry, hard to remember. So when you talk about Cat 1, Cat 2, Cat 3, Cat 4, hopefully this will make a little better brain connection for that. But we have had a whole variety of them in the Central Pacific. Lane 2018, Category 5, a lot of our planning has been only Category 1 through 4. AEN-EEP was a 4. Some of our modeling we've done has only been through Category 4. Like, oh, well, for the Central Pacific, we don't have to worry about Category 5. EOK in 2006 was the last one that we had. And then 2018, we had both Lane and Walaka reach the maximum Category 5 strength. Walaka was the one that moved through the northwestern Hawaiian Islands and essentially destroyed Easter Island and French Frigate Shoals. So that's going to be a theme that I want to talk about too, of what has happened and what could happen in the future and what we focus on for our preparedness. This is a lot of descriptions for each of these categories. I put these in the slide so you'd have them as a reference in the future to take a look at these. The idea being that as the hurricane strength increases, there's a lot more damage. And the important thing to remember about wind speeds is that it's not a linear increase. If you double the wind speed, you don't double the damage. It's actually a factor of power of 8. So a doubling increase creates a 256 time increase in the amount of damage. And that's what we have broken down here. Every 5 mile an hour increase in wind speed, how much more damaging the winds are compared to a 75 mile an hour hurricane. So you have a 75 mile an hour hurricane. If that ends up being 85 miles an hour, that can cause almost three times as much damage just because of the stronger wind field. So that can make preparations for these significant events can be very difficult. So what can we do? I always like to use Hawaii examples in my presentations, but this photograph from Hurricane Ike in Texas is so iconic. It really drives home the point. This was these folks had a house that was destroyed during Hurricane Rita in 2005, and they rebuilt it. And when Ike made landfall, it was the only house standing. And the quote from the Houston Chronicle here really says it all. The building code was forced, it had to withstand 130 mile an hour winds. He even talked about building it higher than needed. He wanted to break in his flood insurance, so he built it higher than it needed to be. It's hard to tell from this picture, but the house is actually elevated. It's 15 feet off the ground. So these are actions that they were able to take. They unfortunately had to have a home destroyed first, but when they built it back, they planned for the next impactful hurricane. And that's where we come into play. This is the sort of thing that we can help mitigate these issues. And when we plan for these possible conditions, the two things we have to worry about is one, planning for those events that have happened in the past, that not planning for what it could be in the future. We've seen lots of instances where, we've never had 49 inches of rain in 24 hours, and that happened 2018 on Kauai and washed out Kuhio Highway and isolated the North Shore for months. Or we don't plan for a Category 5 hurricane in the Central Pacific, and Lane was 300 miles south of Hawaii when it was Category 5 strength. We have wildfires, but we never plan for them to impact a town, and that happened last summer in Lahaina. This is a problem with worldwide. Take the 2011 Tohoku earthquake. The Fukushima nuclear plant was planned for, this is the strongest earthquake we have to plan for, and Tohoku was stronger than that. So going with past history isn't necessarily enough to plan for those future events. And the second item is that we also have a very short history and a short memory. So we talk about people forgetting about AEN-EEP. We start to forget about EVA. 1871, we had a major hurricane hit the Big Island, and linked here in this document is a research paper using Hawaiian language newspaper articles and reports in those publications to recreate the track of the Kohala cyclone. And the paper conservatively estimates the intensity as a Category 3, impacting the Big Island, moving across the Kohala Mountains, swinging up into Maui, impacting Hana, impacting Lahaina. So the things that you hear, Hawaii Island can never be impacted by a hurricane. Maui can never be impacted by a hurricane. Here's reports from past newspapers showing, yes, it has happened in the past. So it's not just a matter of anticipating things new, it's also remembering what has happened before and planning for those. So that's a little negative, I think. A little more, what can we do now personally? I want to plug a book here, a publication from the University of Hawaii Sea Grant College Program, Homeowner's Handbook. It's available free. It's linked on the slides here. You can also pick up, Sea Grant has printed this, and it's available for free as well through public libraries across the state. There's a lot of information in here to help you prepare now. Talking about when your house was built, so what building standards were it built to. They've changed as we've had different disasters. Homes built after the mid-90s, after we updated them after AEN-EEP, are more sturdy than those beforehand. And depending on when your house was built, there's actions you can take, installing hurricane clips, roof tie-downs, continuous load path. There's information in the handbook to help walk you through retrofitting your house to protect it now. And then we've been talking a lot about wind with hurricanes, but it's just one of the hazards. Storm surge for coastal areas, when I talk about saltwater runup, or flooding, freshwater flooding. As we saw in 2018 with Hurricane Lane, 58 inches of rain in 3 days, it's set the state rainfall record, caused flooding where they hadn't had flooding before on Hawaii Island. So those are two things to keep in mind as well. And linked here are resources to the flood threat maps from FEMA, and also the storm surge maps that my agency has created. And you'll notice here, as I mentioned, the highest one we have for Hawaii is a Category 4, because we didn't think to do modeling for Category 5s. Is that an oversight on our part? Absolutely. We didn't think ahead. We were basing it on the past information. And then the other caveat too, I guess to make this more sobering as well, as Chip mentioned, all of our rainfall drains into the ocean. So if the sea level is higher, if the storm drains are blocked with ocean water, it's not going to run off as much, so we'll have more freshwater flooding problems as well. So that's, I'll wrap that up and I guess pause for any questions.
Great. Thank you, John. Any questions, members?
Yeah.
Thank you. And coming from Lahaina and having lived through what had occurred, you know, it was like, is there a way, because that, was it Dora? What was that hurricane below us 500 miles away, which
Dora.
didn't even hit us straight on, and look at the effects that caused, supposedly. I mean, was that the cause for those 59 years I've lived in Lahaina, never seen winds like that?
Mm-hmm. Dora was over 500 miles south of the state.
Right.
And so that's that's something that is being researched now and is a big topic in the American Meteorological Society. Doing some modeling can we take Dora out of the equation and see what winds we've had with that. And I don't know how much of an impact it played. It was definitely outside the wind field from the hurricane itself, but you have a strong wind field between between the high pressure north of us and the hurricane south of us. And then also a lot of sinking air outside of the hurricane. So there's thunderstorms in the middle of the hurricane. That air goes up and then it comes down outside. And it's that sinking air over Hawaii kept conditions very dry, led to the dry conditions at the surface, also led to a very low and strong temperature inversion right over the mountain. And those came together, inversion right at the ridgetop level, ended up with the strong downslope winds. And that's not something new. actually, even in Lahaina itself, there was a wildfire in 2018 before Hurricane Lane, right? It was a shock to a lot of people when people evacuated their homes to a hurricane refuge shelter ahead of the hurricane and then had to evacuate the hurricane shelter because of the wildfire. Like that is not something that you plan for with a hurricane. So how much of an impact? I don't know. Could it happen again? Yes. Yeah.
Okay, and sorry, a follow-up. And then there's a tornado the other day. So these are like just, anomalies, or are they not going to be anomaly, I guess, like a occurring, type of thing? And have you folks seen the reports and changes in our climate obviously has some effect, but where are you folks, tracking that or charting it or?
Actually, that's a great point. I'm glad you brought that up too, because I talked about wind, I talked about rain, storm surge. I didn't talk about tornadoes, which is another threat with hurricanes as well. Usually it's the right front quadrant. So when Lane was coming up here from the south, that was what we were worried about as well, with the spin in the atmosphere. The other night with the tornado warning for Molokai, that's a hazard that we get hurricanes during the summertime, but especially with our fronts, cold fronts and Kona lows and our wet season storms, that tornado hazard is a wintertime hazard for us as well. I mentioned the 2012 thunderstorm on Oahu that brought us our record-setting hail, 4.25 inch size hail falling out of this supercell thunderstorm. We also had a tornado with that. It was a water spout moved onshore in Lanikai. So we have had tornadoes here. We probably don't know about as many as occur because a lot of these thunderstorms, we can see them on radar, they're offshore. We bet there's really nasty weather with them, but there's nobody under them, thankfully, to experience it. And it's a matter of that being a small target in a big ocean. So tornadoes, add that to the list. That's another hazard we have to worry about that exists, isn't well understood, and could potentially be increasing as these conditions get worse in the future.
Okay, well, thank you. Don't envy your job.
Yeah, thank you, Chair. Big Island, landmass of Mauna Kea, Mauna Loa, Hualai, Kohalas. One of the opinions is because of the landmass, we do get a little bit of a high pressure area over the Big Island, which helps fend off some of the larger storms. What's your opinion?
So some of the research I've read on that, hurricanes are really tall structures. Thunderstorms extending up to 50,000 feet, 50 or 60,000 feet in the air. The most influence for steering them, how the winds, they move with the wind. The most influence to their direction comes from about 20,000 feet to 40,000 feet. So that's above the mountaintop level for Mauna Kea and Mauna Loa. So there's not a big influence with that directly. There's also been some research from some students at UH. There is a slight deflection they found with some tracks, but not to a degree that Hawaii, Big Island is safe. It won't steer them away or anything like that. We do know that if something impacts the island, like we saw with Isel in 2014 or Darby in 2016, that once it hits the terrain, it completely disrupts the circulation. And in the case of Isel, it weakened rapidly after that point, and it was a remnant low soon thereafter as it came out the other side. So from that standpoint, Big Island could be a deflector or protection for the other islands by absorbing the impact, but that doesn't help the residents on the Big Island.
Okay, appreciate that. Thank you, Chair.
All right, thank you very much, John.
Cool, thank you.
Folks, we're going to take a 5-minute break. It's 2:26 now, so we'll start about 2:31. Now we have Dr. Victoria Keener. She's the Senior Research Fellow at the East-West Center, also the co-lead principal investigator of the Pacific Research on Island Solutions for Adaptation, which is funded by NOAA, the National Oceanic and Atmospheric Administration, for those who don't know that. And also, she's the author of the 5th National Climate Assessment released by the White House in November 2023. Okay, so Dr. Keeney.
Thank you so much, senators, representatives. It's great to be here today, and really great that there is an opportunity at this scale to really talk about how to link climate change and impacts from the global scale to the regional, to the local, to the impacts we see on our communities and our ecosystems. So it's kind of it's been a good setup today in terms of order of speakers, going from that large scale down to smaller, because really what I'm going to be able to talk about today are results from our Hawaii and Pacific Islands chapter of the 5th National Climate Assessment, which Senator Gabbard said was released by the White House in November of last year, and really concentrates on localizing those impacts on sectors, key sectors in Hawaii and the islands that we care about, the impacts on the people and communities and ecosystems. So as you can see, I'm one of many authors of this chapter, so it's by no means leading it, but one of many. And it's working. There we go. And the National Climate Assessment, this is the 5th one that was released by the White House and the federal government. It's mandated by federal law through the 1990 Global Change Research Act to be released every 4 years. It's a quadrennial report released by the White House to really, again, localize those national climate risks. So like the IPCC report is for the world, the National Climate Assessment is for the US. It's classified as a highly influential scientific assessment, or a HISA, which is really a way for the federal government to get the most up-to-date and trusted information about climate impacts in every key sector and every key region in the US. So as was said, I was an author on the Hawaii and Pacific Islands chapter. It took over 2 years to produce. We had 5 public workshops to shape the key messages therein. There are 16 authors, over 40 technical contributors, and we assessed over 486 references that were then cited in this chapter. But it is very readable, so I encourage everyone to go and click on the link down there that links to the National Climate Assessment for 2023. So climate change, as we have heard, in the Pacific Islands and in Hawaii, it exacerbates inequities. It threatens ecosystems, cultural resources, human health, livelihoods, the built environment, and access to food and water at all scales. It's threatening many of those things that we care about. And one of the ways that we've visualized it in these figures that you see here are through the indicators, which you've heard a lot about today, those technical variables, things like rainfall changing, temperature going up, and then in the bottom panel, the impacts that people and ecosystems see on the ground. So, the carbon dioxide is rising, but on the ground, in the impacts, we see more intense and frequent heat waves, new diseases and risks to health, increased invasive species and wildfire, things like that. But we also know that future greenhouse gas emissions are heavily going to influence what happens in the Pacific after mid-century. So what we've already done as a species has, kind of put us where we are now. But after about mid-century, what we are going to do is going to determine a lot of what our fate is. Some of the things that we're expecting to see and that you've already heard about, warmer air and sea surface temperatures, more heat extremes, more marine heat waves, increasing ocean acidification, an increase in frequency and intensity of heavy rainfall events and flooding, a greater proportion of more intense tropical cyclones, continuously rising sea level, increased coastal flooding, and negatively impacted fisheries and aquaculture operations through increasing sea surface temperatures, acidification, and degraded coral reefs. As we've already heard, at a global scale, everything is getting warmer, but in Hawaii specifically, the number of hot days per year has increased dramatically. The temperature in Hawaii statewide has risen by 0.76 degrees Fahrenheit over the past 100 years, which may not sound dramatic, but if you look at this graph on the upper right, that shows the Hawaii annual temperatures from about 1920 to 2020, and anything in a red is above average temperatures, above climatology, and anything blue is below. So as you can see, as we are getting more current, we're seeing more and more years that are above that climatological average. We've also seen our average number of hot days increased, while the number of cool nights that we get to experience has decreased over time. This is also true across the entire Pacific Islands region. There's a shift across the Pacific to more extreme and frequent daily heat events. And 7 of the warmest 8 years on record have occurred since 2007, and every year since 1983 has been above that climatological average from 1961 to 1990. We've already heard about rainfall trends, so I won't dwell on this too long, but Hawaii rainfall has been trending downwards during wet and dry seasons for decades, with the period since 2008 being particularly dry. Statistically significant trends are indicated on this figure with black hatching. The sharpest downward trends in rainfall are found on the western part of Hawaii Island, although on other islands, significant decreases have occurred in wetter areas as well. Although uncertain, future rainfall projections show continued drying on leeward sides of all islands, with some windward areas becoming wetter. And this is just one example of one of the models that we have that shows a projection of potential future rainfall changes. And again, those red colors indicate drying, and the blue areas are wetter at the end of the century by 2100 under a very high emission scenario. What we also know is that we need organizations, climate boundary organizations like the ones that I work for, academic ones like CHIP's Climate Resilience Collaborative, nonprofit organizations, community-based organizations, acting as climate boundary groups to transform global science into local implementation. A lot of times, as we heard from Chip, policy concentrates on the mitigation of climate change via reducing greenhouse gases, which is essential. However, mitigation without adaptation to the impacts we'll feel and are already experiencing is short-sighted and will disproportionately harm the populations and ecosystems that have been made the most vulnerable to climate change. We know that climate impacts are being felt now, and adaptation is critical. Natural resource managers and communities often need data in different formats and scales, but lack the time and expertise to convert them themselves and do that work. And so these climate boundary organizations are really critical in making that transformation. We also know that new partnership models are needed to do this between researchers, governments at different scales, businesses, and communities. And that we need more relational, non-transactional, and collaborative approaches to adaptation. So for the National Climate Assessment, our chapter had 5 key messages. So in many of these examples, these impacts are happening now. They're not predicted to happen in 10 years or in 100 years. Today's briefs are providing a lot of information with better and better scientific models and information, showing how we're decreasing that uncertainty in future projections. But a message I think everybody should hear today is that we do not need more certain scientific information to act now to mitigate and adapt Hawaii's systems to what we're already experiencing and what we know will only get worse in the coming decades. Our 5 key impacts include, that are covered in the chapter include climate change impairing access to healthy food and water, climate change undermining human health, but community strengths boost resilience, rising sea levels threaten infrastructure and local economies and exacerbate existing inequities. Responses to rising threats may help safeguard tropical ecosystems and biodiversity. And finally, indigenous knowledge systems strengthen island resilience. I'm going to go through each of these impacts briefly, and then at the end, I threw in some policy points where, as this is a legislative body, where it might be most helpful to look at how these key impacts can be reflected in legislation. So in terms of climate change impairing access to healthy food and water, we know that regional food security is negatively impacted by rising temperatures and sea levels. We've also observed in Hawaii across the region that rising average nighttime temperatures and extremes are threatening commercial subsistence and cultural foods. We also see spread of invasive pests, which is linked to increased heat and drought. We know that droughts have become longer and more severe, and in Hawaii are the principal cause of crop loss. And finally, that access to healthy food is an issue of environmental and social equity, with areas of lower socioeconomic status often linked to fewer varieties of nutritious food. And now in these green boxes, which are going to pop up on every screen from now on, I've tried to identify some of the policy places where these impacts might link. So the sea level rise 2022 bullet point refers to the Sea Level Rise Vulnerability Report that was released in 2017 by the state, and updated in 2022. So in that report, there are a great deal of recommendations that are all very relevant, but I've just pulled out some that might be particularly relevant in these cases. So recommendation 1.4 was to balance managed retreat from urban areas with preservation of agricultural and conservation lands. The state decarbonization strategy recommends agricultural best management practices and to consider impacts to frontline and low-income communities. By implementing the Hawaii Green Fee, we could reinvest in local food security planning, support groundwater, and stream flow monitoring. And in the prior session, specifically the Senate Bill 420, which supported establishing Sustainable Food Systems Working Group within Department of Agriculture, could help look at some of these sustainable food options. Next, on climate change undermining human health, this is a figure from the National Climate Assessment that looks at an Oahu community heat assessment that was done by the city and a cadre of volunteers, community volunteers, and it was done on August 31st, 2019. And what they were able to do was map the afternoon heat index all over the urban core and around the coastline of Oahu. And this is just an example of how we're experiencing extreme heat related to climate change. We know that climate change is increasing the frequency, intensity, and duration of heat extremes. On this afternoon that's mapped here, the maximum recorded heat index was 107.3 degrees Fahrenheit. We also know that 82% of heat-related deaths in Honolulu are already attributable to climate change. We also see an increase across the region of vector-borne diseases such as malaria and dengue, which are spread by mosquitoes and have been linked to drought and flood cycles, and we expect that to increase further. In terms of how this links to policy actions in the 22 Sea Level Rise report, Action 2.6 looks at protecting human health via implementing flood design standards. Recommendation 6.1 supports the Department of Health to develop criteria for identification of contaminated sites that are high risk of causing harm due to rising sea level and flooding. They also support a One Health framework and conversion of cesspools. These are all things that relate to climate change undermining human health. The decarbonization strategy prioritizes minimizing health impacts to frontline low and low-income communities. And in the prior session, the Climate Special Impact Fund would have potentially provided funding for all of these initiatives. Key message 3 was rising sea levels threaten infrastructure and local economies and exacerbate inequities. We've heard from Chip and everyone that sea level rise is increasingly going to impact coastal infrastructure, transportation, ecosystems, and communities that are vulnerable. These are only going to exacerbate existing social challenges by disrupting livelihoods, especially in vulnerable communities and areas. Hawaii has enacted very forward-looking state and county policies for sea level rise, one of the leaders in the nation. These include increased minimum setbacks for coastal development, looking at future sea level rise within those setbacks, putting the mandate to disclose sea level rise hazards prior to real estate transactions, which was huge, and a requirement for state agencies to assess and plan for sea level rise impacts. But there is always more that can be done, and those are outlined in that Sea Level Rise 22 report. We also know that degradation of coral reefs due to a rise in those sea surface temperatures could incur additional coastal damages, costing approximately $1.2 billion in 2022 dollars annually to the economies of Hawaii and U.S. Pacific territories. So there is a lot of economic savings involved in protecting natural ecosystems as well. In terms of policies that are relevant, in the sea level rise report, seek opportunities to plan new development outside of the sea level rise exposure area under long-term comprehensive managed retreat strategy, develop pre-disaster recovery frameworks at state to county levels that include sea level rise, and again, cesspool conversion. With the green fee, reinvest in supporting sea level rise strategy recommendations. And from the prior session, again, the Climate Impact Special Fund, erosion rate disclosures, tax credit for wind-related retrofits, and rebates for EV-ready infrastructure at affordable housing, and the DLNR Managed Retreat Program are all things that could have been relevant. In terms of ecosystem and biodiversity, we know that fisheries and aquacultures will be negatively impacted by increasing sea surface temperatures, acidification, and degraded coral reefs. This results in reduced commercial and subsistence catch, smaller fish sizes, and degraded reefs. We also see that increased drought is going to accelerate that contraction of ranges of endemic and endangered plants and animals in the islands. And we have seen through examples that regional efforts and in Hawaii, efforts that increasingly focus on restoration management that enhance climate resilience, you get a double win for that type of adaptation. You're boosting adaptive capacity. You have hydrological benefits such as aquifer recharge, sociocultural benefits, carbon sequestration, and sediment retention. I wanted to put one more figure from the chapter up that looks at wildfire area burned in the Pacific Islands compared to the Western U.S. So this is relevant because wildfire area burned has increased fourfold from the early 1900s in Hawaii and is most prevalent in non-native grasslands and shrublands, which we saw in Lahaina recently. We also know that climatic shifts are expected to impact native ecosystems negatively via interactions with fire. And as shown in this figure, wildland fires already burn a higher proportion of total land area in the Pacific Islands than in the continental US. So in terms of policies, the Sea Level Rise report looks at exploring legislative and policy mechanisms to designate funding for priority coastal lands, enabling existing programs to acquire beaches and lands for recreational, cultural, ecosystem, and resilience objectives. Other relevant policies can include supporting watershed-based restoration, the Hawaii Watershed Partnerships Program, wildfire management, and additional human resources on all of those. In the prior session, the Climate Impact Special Fund and the carbon fee are both relevant to this. Finally, we saw through repeated examples across the region that indigenous knowledge systems strengthen island resilience. Climate change affects the health, well-being, and modern livelihoods of Pacific Islands peoples. And climate is already, one of the ways that they're being impacted is affecting cultural sites that show that heritage of interconnectedness of the environment with Pacific peoples across the region. We have examples of communities and cultural practitioners working with scientists to identify area where food production, such as taro, breadfruit, and sweet potato, could be expanded under future climate scenarios. And adaptation actions, such as community-based subsistence projects that restore ecosystem services and enhance community resilience. They also have the other benefits of increasing local food production and diversifying the local economy. So in terms of policies, conserving and adapting Native Hawaiian cultural resources and site, working with Native Hawaiian communities to develop culturally based adaptation processes, adaptation to preserve access to coastal lands and waters within Native Hawaiian communities, support community-led adaptation projects, support watershed-based protection and restoration, and this could all be funded through a Climate Impact Special Fund. So finally, I wanted to end with just a kind of a overall plea that a lot of times we hear that Hawaii is too small to make a difference on a lot of these climate change impacts, both mitigation and adaptation. but local policies can accelerate regional resilience by replication across sectors and across islands. We know that at higher warming levels, we're going to experience more severe climate impacts, but local interventions can mitigate some amount of climate risk. And by including local organizations and communities as partners to co-develop these plans, we're increasing our adaptation and resilience as well. We already have future scenarios of climate change to provide a range to plan for, depending on a system's risk tolerance that can be really used at a state level to prioritize actions. We have worst case scenarios and best case scenarios that can identify high risk investments and minimum adaptation requirements. We want to prioritize partnerships that integrate and prioritize cultural knowledge and natural resource management. And finally, as part of this learning, we want to promote peer exchange. What are adaptation strategies that are transferable across sectors and across islands, not just within Hawaii, but across the region and across the globe? And with that, here's a citation to the chapter if you're interested in diving into more exciting findings that weren't covered here today. You can contact me anytime. There's a chapter webinar by all of the authors. It's going to be on February 13th, and that'll be recorded. You can register here. And there will be a White House release event for the chapter here in Honolulu at Hawaii Climate Week on March 27th. More info on that soon. Thank you.
Thank you very much, Dr. King. Members, any questions, members?
Yeah, thank you. Very informative. Question, you talked about acidification of the oceans. Is that because of carbon dioxide? Is that what you're...
Yes.
Okay, and is that cyclic or is it trending? What's happening there?
So this is outside of my area of expertise, but it's definitely becoming more acidic over time, so a long-term increasing trend. I don't know if it's cyclic.
Okay, and I just was wondering, because we've had a lot of problem with acidic rain because of the volcano. I was just wondering if that's being used part of modeling, looking at the near shore waters or anything.
Yeah, I'm pretty sure that the models that look at acidification do include volcanic activity, but a lot of this is based on observations and actually, from Station Aloha above the state as well.
Thank you very much. Okay, moving on. Our next speaker is Donald Aviao. He's the Executive Officer of Hawaii Emergency Management Agency, or HEMA. He has, let's come forward. Aloha, Donald. Donald has 9 years of service with the U.S. Air Force and also more than 30 years of experience, including as a senior instructor with the National Disaster Preparedness Training Center at UH. And he became the executive officer of HIEMA in June of last year. Welcome.
Aloha.
Aloha.
So, I guess we go through the slides. Yeah. Okay. Oh, okay. Good morning. Good afternoon, rather. Sorry. Been quite a long day, so I know for you folks as well. I just wanted to give you a brief overview of our agency, the Hawaii Emergency Management Agency. Our mission is to help Hawaii, Ohana, prepare for, mitigate against, respond to, and recover from disasters. So that's been our main mission, and for from the founding of the agency. And we do have that slide that says the next slide. That kind of also is much like our national FEMA agency, right? Preparedness, mitigation, response, and recovery. And it's more so highlighted in the recent Maui wildfires of what we're trying to do now and currently and into the future. So, and of course, again, our hearts go out to the survivors of the Maui wildfires, and for all of those that are continue to support the operation, first responders, our leadership, our legislature, and our governor. If I missed anybody, I apologize, but it is it's a cup thing for me, and as well as our administrator to be where we're at this time. Being with FEMA for all these years, I worked there for 6 years before coming to HIEMA, and I understand the timelines that these things take, and we have a far, of accelerated schedule from with the help of FEMA, and of course the president, and of course the governor. And the mayors of our counties they've all worked together, and I appreciate the legislators and their efforts in helping this, which will, in this Maui wildfire disasters as well as future disasters that may impact on a statewide, scenario. So I'm hoping that, that never happens, but, just seeing how everybody's working together and coordinating, not everybody may be happy, and like my wife always tells me, you're not gonna make everybody happy, but it's good. It's part of the process. So, we're gonna work it out. And of course,
You got to make her happy, though, right?
yeah. So I just wanted to add also, Haima, our core values, and part of what I've just said is to, we do have 5 that we always, try to remind ourselves and our personnel, and then for our federal partners, is to malama, to care for and protect, po'okela, striving to undertake every action with excellence and ensuring continuous improvement, vivo ole, which also means courage, but serving the people of Hawaii with courage and fearlessness. Kupono, to be honest, fair and transparent and open. And of course, the biggest thing that's been part of this whole process is Laulima, to cooperate and work successfully with others. So if we go to the next slide, just kind of our structure is the Office of the Governor on the top, and then the overall department is Hawaii State Department of Defense. And then our Director of Emergency Management is, of course, you all familiar with the Adjutant General, Major General Kenneth Hara. He is our main director. And then we have the Deputy Adjutant General, and then we have the 6 divisions, but now 5 because the Office of Homeland Security has transferred over to the Department of Law Enforcement. So our other 5 agencies, of course, besides ourselves, is the Hawaii Army National Guard, Hawaii Air National Guard, Office of the Veteran Services, and of course, the Youth Challenge Program. And then finally, our more of our specific being our Haima agency. Again, it's the director is our the tag, or the Adjutant General Hara, and then James Barros is our administrator, and then myself as the executive officer, and then FEMA falls into that also in helping us as our federal partners. We do have 5 separate current operational divisions or branches, which is our operations or logistics, resilience branch, finance and administration, and external affairs, which have been very heavily tasked, being a small agency with our current disaster. So, and along with our county partners, Elton Ushio with Kauai County, Hirokazu Toya for the City and County of Honolulu, Amos, who just got appointed, Lono Kailua Hewitt for Maui County, and Talmadge Magno from Hawaii County. So that's pretty much our layout of our agency, as well as some of the things that you may not have known about the other partners that we have within our emergency management field. So from there, I'm passing it over to our State Hazard Mitigation Officer, Kelsey Yamanaka.
Thanks, Don. Mahalo to Chair Gabbard and Chair Lowen for having us today. Climate change is exacerbating the impacts of hazards that we know we're vulnerable to today. Oh, sure, sorry. Thank you. So climate change is exacerbating the impacts of the hazards that we know we're vulnerable to today. And that's why hazard mitigation is so important. Hazard mitigation is reducing or eliminating the long-term risk to life and property from hazards. So I'd like to talk to you about some hazard mitigation opportunities that are coming up. First off, the slide shows the governor's hazard mitigation strategy. So this is his overall strategy. The state is committed to executing priority projects identified in mitigation and recovery plans. We don't have to start from scratch. We have existing projects that have been identified as being mitigative, and we need to help fund those. So we're here today to talk about one funding opportunity. The state is also encouraging projects that mitigate against multiple hazards and incorporate nature-based solutions like coral restoration and incorporating emerging technologies. And of course, we also want to encourage projects that reduce the community's long-term vulnerability to natural hazards. The recent wildfires unlocked FEMA's Hazard Mitigation Grant Program, and that's the funding opportunity I'm here to talk about today. The governor released his funding priorities for this Hazard Mitigation, or HMGP, grant program. Thanks. And I won't list all 6, but just to touch on a few, we want to strengthen resilience for critical facilities and critical infrastructure. We want to benefit the underserved and underrepresented communities, and we also want to prioritize projects that will benefit the areas in the declared disaster. And the copy of the governor's funding priorities and funding mitigation, the mitigation strategy can be found on HIEMA's Hazard Mitigation Grant website. Next up is our hazard mitigation program timeline. So as you can see, we're just in the beginning. We've received FEMA's 30-day funding estimate. We've posted our notices of intent over collecting project proposals. We've released the state's priorities, and now we're waiting for FEMA's 6-month funding estimate. And this estimate is based off of FEMA's public assistance and individual assistance programs, and that is focused on recovery. I'd also want to mention that there is a non-federal match required for the Hazard Mitigation Grant Program. Right now, it's at a 75 federal and 25 non-federal cost share. So every project that comes in, the community or the county, state, or private nonprofits that apply, they do have to put a 25% cost share into that project. And with that, I'll pass it over to my colleague Ethan Oki to talk about HIEMA's community outreach initiatives.
Thank you, Chair, Chair Lauren and Chair Gabbard. Just to clarify, I'm actually stepping in for our community outreach person, John Vieira. Unfortunately, he was unable to attend today due to some meetings that he needed to attend in Maui in regards to our long-term housing efforts. So with that, I'm just going to continue on with the slide. Next slide. So overall, for our community outreach, our priorities is to strengthen our partnerships, whether that partnerships deal with our federal, our state, or our county partners. We want to make sure with this HIEMA administration that we're working together, right? They all have their facets, their subject matter expertise. Our goal is to strengthen that as a kako kind of perspective. Like, we're all doing it together because it's going to impact all of us as one. We're going to develop those relationships with our partners. We're going to build community resilient hubs, strengthen and align operation plans, and then also we're going to revamp what existing HHARP program that we have. We're kind of rebranding it with HHARP 2.0, which in the next slide, the goals for the HHARP is to enhance the resilience for our communities, promote and understand multiple hazard and actions to be taken, leverage leading resources, best practices for disaster mitigation, preparedness, response, and recovery, and tap into cutting-edge tools to protect ourselves, our families, and our loved ones. So we have a handout that we're going to email all of you and follow up to this informational briefing that kind of goes over that. And ideally, the administrator's goal is to identify what existing HRs we have and then also build up from there. The goal is to have 10 statewide HRs, fully functional, that are going to partner with not only the state but as well as the counties in regards to any emergency management situations. So with that, I'm going to pass it back to our expert.
Okay, thank you, Ethan and Kelsey. Appreciate the information. Yeah, the HR program is to empower those communities, statewide to, be resilient and be able to respond and recover from a disaster. So by doing so, that the community will it's a lot easier to have the community members that are identify with each other, that already have networked with each other, find out their strengths and weaknesses a lot quicker. And, of course, like I said earlier, it's a cockle thing, and everyone wants to benefit and work together in trying to get back to normalcy. In closing, for ourselves, as our Kelsey had mentioned, we do want you to support Governor Green's climate change mitigation proposals. It will provide needed monies for projects such as fire breaks and, of course, evacuation route, access road improvements. In previous informational briefings, the evacuation routes was brought up, and it is an important component, especially out on your side, Senator Gabbard, on the west side. They are looking at the Hawaiian Homes routes, and of course, our logistics chief did I had a visit with the Army where they brought a group of people to look at the Kolikole Pass as one of the evacuation routes as well. So that climate mitigation proposal, change proposal, will help us improve those roads, have monies to do so, and not so much tap into the state general funds for it, and as well as our CIP budgets, which everyone else has other needs, including education. And we understand that. And also can be for our counties or municipalities, they also provide a local match that we can provide from those fees. And a lot of that, as I've seen with FEMA, it's difficult for counties. And I'm sure you understand, being on the council, Maui County Council, that it is difficult for county councils because their budgets are small. And this will help them, raise money to have the local match once we do all these projects and as we get it started. Of course, Maui, we do have the disaster, but we're talking about statewide. It will benefit the statewide once we get all this in place. Other than that, if there's any questions.
Okay.
Yep.
Members, any questions? Rep. Lauren?
Have you, in your list of hazards, do you include heat and extreme temperatures among your list of hazards?
We just published our state hazard mitigation plan, and that was started kind of before we had enough information to put that as a listed hazard. So at this time, we do not list it. However, we are touching it at least every year to provide small updates, and then every 5 years, we will update it, the whole thing.
So has it been discussed already within HIEMA that ought to be included as a consideration or a condition that there might need emergency response for?
Yes, we received some public comments that suggested putting that hazard in this plan, but we just unfortunately didn't have the time since the plan did expire, it was expiring, so we wanted to ensure that we would be eligible to access some of these FEMA hazard mitigation funds. So yes, we are looking into it and having internal discussions for the next update.
Thank you.
Thank you. Okay, thank you very much. Thank you for your service. All right, our next speaker will be Tammy Lee, the Deputy Director for Administration for the Hawaii Department of Transportation. Is Tammy here? Here she is. She's had many years of service with HDOT, was the Business Management Officer and Contracting Officer, and she assumed her current role in December of 2022. Tammy?
Thank you, Chair
Friends.
Gabbard. Thank you, Chair Lowen, Senator Richardson, and Representative Cochran. Thank you. I'm Tammy Lee. I'm the Deputy Director for Administration for the Department of Transportation. With me today, I brought a team. Dr. Pradip Pant, he's our Statewide Transportation Planning Office Manager. Ken Tatsuguchi, he is our Highways Planning Branch Manager. And Shelly Kunishige, she is our Infrastructure Coordinator. But thank you so much for having us today. We were outside listening to all of the presentations, the causes, the impacts, and the emergency preparedness. We're excited to be here. We know that at the DOT, our understanding of everybody and all the science that came before us and what is changing, we're focused on making some tough decisions to ensure the long-term viability of our transportation infrastructure. The DOT is doing its part to be more resilient, adaptive, and engaged in climate change risks to our port and highway networks. Okay, so starting with our airports. The 15 airports managed by the DOT are an important driver for Hawaii's economy. 37 million incoming and departing passengers travel through our commercial airports annually. We also have 13 of these commercial airports. We have 2 general aviation exclusive airports as well. To plan for these needed actions, we use modeling using the best available data to determine the potential future exposure. From the models, a projected extent of flooding due to sea level rise, called the sea level rise exposure area, was studied. Next slide. Thank you. Okay, so this slide shows with the red starred the impacted airports that are impacted by the sea level rise. These preliminary figures were obtained by overlaying the sea level rise exposure area, 3.2-foot flooding layer over the airport area footprint. The accepted sea level rise forecast is that inundation would occur at 10 of our airports. Next slide. So this, it's kind of small, I can't see too much from here, but basically what it's showing is that the general aviation airport, Port Allen, would be impacted the most with about 29% of its area overlapping the sea level rise exposure area. More importantly, commercial ports, Kahului Airport and Daniel K. Inouye International Airport would also be significantly impacted at 13% and 9% respectively. There are only 5 airports, Hilo, Kapalua, Lanai, Molokai, and Waimea Kohala airports will not be impacted by this sea level rise model that we did. Based on our preliminary studies, we developed adaptation strategies, and the considerations for the airport are to construct shoreline revetment seawalls, elevate runways and taxiways, or retrofit facilities. Additionally, retrofit all facilities by reconstruction and modification to at least 1 foot above the projected sea level rise elevation over the next 100 years, or to relocate the airports to higher elevations. But currently and in the future, to build upon the work that we did for these models for sea level rise, is finishing our sea level rise adaptation plan and our climate adaptation action plan. And basically what we're going to be studying with those plans is to capture all of the potential risks to our airports, and not just sea level rise. It would include severe storm events, extreme precipitation and heat, wildfires, tsunamis, and lava flows. Next slide. So moving on to we maintain and operate 10 commercial harbors. Hawaii imports 80% of all of its goods, and 98% of that imported food and goods are delivered through the harbor system. The maritime transportation industry is much larger than the air cargo industry when measured by the volume of goods transported. Next slide. Like the airports, Hawaii harbors are vulnerable to sea level rise. As freeboard, or the height of a ship's side between the waterline and the deck, decreases due to sea level rise, ports might have to raise structures. Adequate height is important for commercially safe operation of piers as well as maintenance of the pier structure. Substructure erosion and flooding are also of concern to harbors. Our options to address these vulnerabilities are, the studies are showing that should there be better drainage, or should the decision be made to raise pier heights? And these are the options that we're looking at. Other ports, we've done some studies on other ports, and while other ports' geographies are so different from Hawaii's, what we can glean from other ports is recognizing or maybe mimicking the same approach that they take to make decisions. Next slide. This image shows the impacts of the 3.2-foot sea level rise exposure area, flood area on the Honolulu Harbor. As you can see in blue, it's not just the harbor area, but it reaches out to portions of Kalihi Kai and Kalihi Palama. Next slide. These are depictions of the sea level rise on our other ports. We have to kind of consider the surrounding properties, and that's what the takeaway that I wanted to show these slides, is for us to consider the surrounding properties not under our control and collaborate with those landowners. Next slide. Okay, so as I showed in the first slide, we have differing options. One of them is a sheet pile solution. In 2020, we advertised improvements to our Kapalama terminal yard in 2020. We accepted bids, and these figures here are, should there be a determination to make improvements to the harbors using a sheet pile solution, it would be very expensive. For the KCT project, what we did was we used sheet piles to raise the container yard. It was 7 feet above sea level. We raised it 2 more feet to 9 feet, and it allows the 2 feet increase. And basically, it was very expensive. We did a rough order of magnitude to project out to today's numbers, and it would basically cost us about $2.5 billion if we were to decide to go this route. Next slide. Okay, so finally, our highways. We issued our climate adaptation plan in 2021, and it built on several other studies that we've done. Most notably in 2019, our Coastal Highway Program report. Basically, that just focused on the coastal highway, but the climate adaptation plan considered a bunch of other stressors. I want to say 8 in total, and it expanded the hazards that we considered in our shoreline study, because we only considered coastal erosion. So it provides more of a comprehensive look at our overall state highway vulnerability to climate hazards. Next slide. So these are just examples of our climate exposure on the stressors that we studied in our climate adaptation plan. Past and current impacts. For landslide and rockfall, these segments are associated with sites that were prioritized in our rockfall protection program and sites determined to have high and very susceptibility according to the United States Geological Survey. So the next picture to the right of that, that's a picture from DLNR of Lahaina. And basically what we wanted to show is that due to the history of many of our roads being belt roads, meant to connect communities separated by valleys, there are many communities with only one route. For example, we use the wildfire emergency proclamation to build emergency routes. Lahaina Luna High School was the one that we used most recently. We use the emergency proclamation to quickly construct these emergency routes. Storm surge. This picture is a photo of a storm surge on Kamehameha Highway in Ka'a'awa when Hurricane Douglas passed through the islands. That flooding picture to the bottom of the landslide is from June 19's thunderstorm. Coastal erosion, that's a picture of early 2020. We implemented a $2 million fix to protect Kamehameha Highway in Hauula and Ka'a'awa when parts of the route were undermined. Additional mitigations we projected at a cost of over $120 million are planned within the next 5 years. As we know, Madame Pele will tell us when there's going to be a lava flow, but also volcanic eruption studies reveals that rising sea levels melting glaciers, depletion of aquifers, and erosion of mountains can all impact the likelihood and frequency of volcanic eruptions. And Eddie would go always, and we're always stoked about big wave action, but it could be detrimental to our infrastructure. Next slide. Okay, so this is more of our climate adaptation plan, and what this is showing is we focus on the state highway network as the focus of this study. And of the total mileage on the state highway network, 564 miles, or 58% of the network, are exposed to one or more of the climate change stressors that I talked about earlier. Next slide. So drilling down deeper, I talked about the climate adaptation study, but this came before 2019, where we did a study on our coastal highways and the impacts of coastal erosion. We identified priority state roads for erosion control and shoreline remediation based on this Coastal Road Erosion Susceptibility Index. This shoreline study looked at 300 discrete coastal highway segments across the state and prioritized them using this new ranking system. Next slide. So this slide is showing that the Coastal Road Erosion Susceptibility Index, top 10 sites, 6 of them are on Oahu. Next slide. So some of our strategies for rockfall mitigation include rock scaling, netting, and other systems to catch or deflect rocks. We all remember in 2019 when we had to close the town-bound pulley tunnels to kind of to construct this rock shed system, which cost $22 million and took approximately 10 months to construct. To install similar protections on all of our sites would cost over $100 million. Next slide. But this is what I wanted to show towards the end of this. And in 2020, we partnered with Google and Carto to develop this platform called the Climate Insights for Infrastructure. And basically, it's just a more user-friendly with overlays of equity, overlays of our assets, such as our bikeways, our pedestrian walkways, and overlays of all of the climate stressors that I talked about. So I put the URL on there. We have this GIS map, and the public can go in there and kind of play around with all of the different layers. Next slide. And this is our internal tool. Beginning in 2019, we developed a resiliency policy. And basically, we want to make sure that internally we take care of ourselves. I mean, we take care internally that we're coordinated to take care of our infrastructure. And basically, what this kind of new query does is that our project managers, before they start to do scoping on a project, they can take this kind of quiz, and from there, based on the information, we can do assessments of the most cost-effective design and investment responses to start early. And to conclude, moving forward is to build resiliency into our transportation infrastructure. That means that our system has the ability to anticipate, prepare for, and adapt to changing conditions, and to withstand, respond to, and recover rapidly from disruptions. Thank you.
Thank you, Tammy. Tammy, one question is, when you're talking about the airports, is sea level rise flooding the only concern for the airports?
No, it's not, and that's why we're doing that climate adaptation action plan to see what the other stressors are and the impacts to our airport facilities, such as wildfires and torrential rains and the like. And the like.
Members, any other questions? Senator Richardson.
Yeah, thank you. I really like the fact that you put some numbers onto the piers, gives us an idea. Have you come up with any estimates for the highways? Because you have a $2.5 billion price tag for our piers. What about the highways? What about the airports? And I won't hold you to it yet, but any idea?
Okay, for highways and the sea level rise impacts, 15 billion,
What, 15
$15 billion.
billion? And airports?
For the airports, we're still doing our climate adaptation plan, and I think from there, we're going to start to do stakeholder involvement going out into the community towards the end of fall of '24. So we're not quite there yet, something that we're working on.
All right, yeah, just, and the reason I asked is just to put it in scale concerning the state budget, state GDP, and that's a big bite. Okay, thank you.
Thank you very much.
Wait, one sec. Can I get?
Okay.
Yeah, and thank you for I saw the numbers for Kahului Airport, because it's our main airport. You mentioned you're gonna have stakeholder meetings come end of this year, in the fall. So, yeah, thank you for that, and I definitely want to be a part of that. And thank you for the alternate route out of this, basically off Lahaina Luna Road, in particular for the schools up at the top. And has there been discussion, though, like a northern route, evacuation route out of the schools? Because as we know with the wildfire, Lahaina Luna Road itself had been, affected, and people got trapped and what have you. So if that occurs again, the people are really, and I live right there off Lahaina Luna Road myself, so, a northern route that hopefully, my number one CIP ask also is the extension of the northern route of the bypass itself. So just wondering what you folks have comments at this time on that? Any discussion being had about it?
Hi. So you mentioned the northern side of the bypass. So we are looking on continuing that portion. That's from an old EIS, so that would probably have to go through re-evaluation if we move forward with that. But that is being considered based on what's happened. Thanks.
Okay, we're considering it definitely critical infrastructure at this time, life and death situations too. So, yeah, I'd like to get that on the priority list. And also, I see number 2 is Maui for the susceptibility roadway, which it looks like it's the mile marker 14 area, Olowalu Ukumehame. So number 2 meaning, is that gonna happen then, since it's second on your list of priorities, or what does that mean?
Is that the one we're working on? Yeah. So I hope I get this right. So we're currently in the environmental stage for moving the road Malka from basically the tunnel to Olowalu. So that's, I think we're planning to go into design build maybe next year. Just to share with everyone, there's moving the road Malka, which will occur with a lot of, I guess, future projects if we move it Malka. There's a lot of environmental issues and property owners, so that's actually maybe something I can share that's taking a lot of time in the environmental process.
Okay, well, thanks. We'll be in touch, I guess, on all that. Thanks.
Thank you very much. Okay, next up is Ernie Lau. Ernie is the manager and chief engineer at the Honolulu Board of Water Supply. He was the manager and chief engineer at Kauai Department of Water from 1996 to 2003, and was also the previous deputy director of the State Commission on Water Resource Management. Aloha, Ernie.
Aloha. Let me see if I can figure out how to share here. Okay. If you could bring up my slides, I haven't figured this out. Okay. Thank you, everybody. Ernie Lau, Board of Water Supply. Thank you for inviting me today, and it's been very enlightening to get an update on climate change and its impacts. And Dr. Fletcher always scares me. I don't know if I can get a sound sleep tonight. I might have some nightmares. But Chip's been great, and everybody else. But the reality is sinking home even further that we have to deal with this situation of climate change. And he did point out water resources in his circle of different things or factors, water resources. And Ola Ikawai, water is life. We live in an island, of course, and we all know this, how precious our water resources are. Let's see if I can get this to work. Next, please. So we did do an assessment back in 2019, working with the Water Research Foundation. They're a national research organization. They provided some of the funding, and using our consultant Brown and Caldwell, look at the assessment on our water resources and our infrastructure. Next, please. Thank you. And these are the objectives of the study. I won't go over them, but basically, look at the impact of water supply and also coastal system infrastructure, and come up with some strategies to address climate change impacts 2100. Next. Just a reminder, we supply almost 1 million people every day with safe drinking water on the island of Oahu, almost 1 million people. And we have to produce about 145 million gallons of clean, fresh water, safe drinking water to meet the needs of our community. And it takes a tremendous amount of infrastructure. Next, please. And this is the approach taken during the study, looking at sea level rise, temperature and rainfall impacts, looking at infrastructure adaptations options, also water supply adaptation options. But I can see after the discussion today, and especially when John Bravender from the National Weather Service talked about what the future might hold in terms of more intense storms, Category 5 hurricanes, that we also have to take another look at the vulnerability of our infrastructure to that very threat. Although short-term, it can be very significant on our island. Next, please. And of course, Dr. Chu and the work of the University of Hawaii, and I appreciate the University of Hawaii, the research they're doing, that's very important to our future. The other aspect with the University of Hawaii, if I could say, is also preparing the next generation, because the climate change issue is not the challenges of only our generation today. It is going to be for generations to come, even more than 7 generations to come, to deal with this situation. So preparing the future that will be responsible to deal with this. Next, please. And the issue comes down to resource capacity for our island, our freshwater resources. And this is a little dated, it's from 2019, but we looked at 2 scenarios, dry and wet scenarios, based on the modeling, dynamical downscaling of global climate models, and also taking a statistical approach. Next, please. And between the dry and wet, there was a potential reduction of maybe over 130 million gallons a day of freshwater resource capacity, which is going to be very significant. And these are just some of the actions or mitigation strategies that we are undertaking. Next, please. The other impact, and I appreciate the Department of Health and the Department of Transportation, I misspoke, the DOT, and we work very closely with the DOT because where the state highways are, a lot of times our large pipelines are located, and it's around the island, and particularly along the leeward areas and in the windward areas, we have large transmission pipes moving water around for our community. And where those highways move or relocate in the future, we will have to go and coordinate with them the relocation of our infrastructure. bridges are a vulnerability for us too. Either pipelines go underneath the stream where there's a bridge, or they're hanging on the bridge itself, the bridge structure. So when the bridges get redone, we have to work with the DOT, and they've been great to work with on addressing it. But bridges are a coastal vulnerability for us also, for our infrastructure. Next, please. And inundation, of course. And this is only at 3.2 feet, and Dr. Fletcher probably say we should be looking at much higher levels of sea level rise. Right, Chip? But the issue is going to be pretty significant, and where this inundation is going to be occurring, it'll impact the urban areas, but also remember, under the roadways are a lot of infrastructure gets impacted. Board of water supply, storm drains, sewer systems, underground electrical systems, gas, telecommunications, they're all going to be impacted. So the coordination is going to be very important in how we deal with that so that we coordinate together and we're working with each other as opposed to against each other. Next, please. And for a lot of our pipelines, there's still metal corrosion issues when they become exposed to seawater, actually inundated in seawater, either partially or all the time. And how we address the issue of corrosion of these pipelines. Next, please. But I also like to point out, and I know Chip used this photo too, it's actually this is a water main break we experienced a few years ago on Nimitz Highway near Alakawa, on the road to Costco out there. 16-inch pipeline on Nimitz Highway. You can see on the left there, the pipe is exposed, but during high tide, the pipe is underwater. So these become operational challenges, and how to dewater when we're dealing with, in this case, petroleum contamination. You can see that black area in the water, that's fuel, old fuels that are still there in the environment. And with sea level rise, those things will get closer to the surface, and at times will surface on the roadways during these periods. Or our infrastructure will be always underneath them. So the challenges are operationally, how do we address this? And this is not only for the Board of Water Supply, but with anybody with underground infrastructure. Next, please. One of the things we've done at the city, and I guess I'm the only city member here working for the city and county of Honolulu, is the idea we take a one water approach which looks at water of all different types, and we look at collaboration, how we want to work together to address this. So one approach here is actually to use $4 million in federal grant funds, fiscal recovery funds, to actually come up with a one water plan and a collaboration framework so that we can start to coordinate our capital improvement projects and work together. I think that one thing that I don't hear a lot of discussion about is these actions to address climate change and the impacts not only to critical infrastructure like ourselves. It's going to take a lot of money. It's going to take a lot of investment. How do we finance these things and still balance that with affordability for for us, it's the water ratepayers, but also for the taxpayers. But it's important that we make these expenditures, and how do we do it efficiently and just at the time that we need them to be done? And how do we finance them in the future? I don't know the answer to that yet. But this, using this $4 million, we're going to come up with a plan at the city level to look at how we can collaborate and coordinate better to address some of these challenges. Next, please. And I just want to say that we have an Office of Climate Change, Sustainability, and Resiliency led by Matt Gonzer. That is a permanent city organization there that looks at this issue full time, and then they help to coordinate the different city agencies, including DPP and others, to address these issues. So I really want to take my hats off to Matt and his team there. They're developing something called a Climate Ready Oahu plan that I think is going to go before our city council in the near future. But it's also involving the community. So the key is not only understanding the science, the impacts to the utility providers, the infrastructure, the owners of those, but also how do we engage and involve our communities in the solutions, because this is going to take, we're going to have to be able to do this together, and we're going to have to find a way to have difficult conversations and come up with solutions that we all can support and implement, and it's going to involve everybody, our community especially. And mahalo, that's all I had to share. Thank you.
Thank you, Ernie. Question for you, Ernie, on, with sea level rise, is saltwater intrusion, is that a concern in terms of with the aquifers?
That is going to be a concern. We are fortunate in portions of Oahu, good portions, we have cap rock formation that is helping to protect the freshwater below, but it is not completely, it's not complete protection, because I think that some of our water sources that are in coastal areas near the coastline, they may start to see impacts there with sea level rise, saltwater intrusion. But also the other thing that Chip pointed out was remember our underground aquifers, especially the basal aquifers, are basically freshwater floating on top of saltwater in the volcanic rock below our island. And as that saltwater moves up with the rise of sea level, that's going to put pressure to move the freshwater higher to create localized flooding, but also affect the aquifer itself. Our wells are fixed points of extraction of fresh water. They're drilled to certain depths. So as the transition between the salt water and the fresh water widens or moves upward, are we going to start to see increased salinity on some of our deeper wells? So we're going to need to look at that very closely. I just want to say that because of that, and for other reasons, we are going to embark on our update of our 30-year master plan, our water master plan, which was adopted back in 2016. With all the challenges we see today, it's very appropriate. And one of the focuses is going to be looking at our water resources, how we use the groundwater resources. We are going to have to prepare for long-term drought. I don't have a crystal ball to say that will be 100% happen to us, but long-term multi-year drought has happened before in Hawaii, and maybe that's going to happen again, maybe for longer periods of time, maybe even permanently. And how do we adjust? How do we look at how we manage our existing resources, but also look at alternatives? Some of the alternatives is seawater desalination, reuse of wastewater, again, taking the one water approach, water of all types, managing stormwater as a resource, capturing and retaining it for recharge, for reuse. Maybe even someday, reusing wastewater even for drinking, which is what California is actually looking at right now. I'm not there yet, and it's probably beyond my lifetime, but we have to look at all alternatives. Enhancing and protecting our watersheds is going to be critically important, senators and representatives, because that is the sponge that captures the ua that falls on our island. And if the amount of ua falling on our watersheds decreases, then we have to make sure the sponge or the watersheds are as efficient and effective as possible to capture whatever limited fresh water is falling upon them to recharge our underground aquifers. And I don't want to leave this out. Water conservation. We need to learn how to use less fresh water in our daily lives. Compared to some of the other locations, other states, they are using less per person than we are. And I think we can do better. Living on an island, we have motivation. We can't import water from the Colorado River or another state. We have to live with what we have and look at expensive alternatives. So water conservation is part of the story too, managing the demand.
Thank you so much.
Thank you.
Yes. Go ahead.
Thank you, and thank you for your knowledge and background. I can tell you're very passionate. So the preliminary supply adaptation strategies, you kind of hit on the desal and toilet to tap concept possibly one day. So the lettering in blue, is that ongoing, or are these just recommendations?
Can somebody bring back
Is
that slide?
I don't know what slide number.
Yeah.
There's a number there or something.
Hold on, let me bring it up on my iPad here. Okay, I can go down the list. So aggressive water conservation, dual plumbing with recycled water, and we're actually really a strong proponent for on-site reuse. So gray water recycling is probably the first step. Stormwater, rainwater catchment systems on buildings. So you're capturing and using the water that falls on the site. Reuse of condensate water from air conditioning systems, all of that reused on site. Maybe showers and shower water, clothes washing, you reuse of that. We participate in a National Blue Ribbon Committee on water reuse, and they're looking at all those things across the country. Stormwater capture at Nuuanu, that's an ongoing study that we're doing. Nuuanu Reservoir number 4 is a large dam that used to have catfish fishing, and we're looking at, can we capture the storms that are shorter duration, high intensity, capture that stormwater, don't let it run into the ocean, treat it, and recharge the aquifer. Expanded reuse at Honouili, Mililani, Waihawa, and Waimanalo, yes. On-site gray water reuse, I kind of mentioned. Moving water around, that's already happening. Addressing the challenges of the public trust rights for domestic water and water for traditional and customary practices. Though that's a challenge that I just tell you, I don't have the solution yet, but we have to find a way. Seawater desalination, desalinated reuse, indirect and direct potable reuse of wastewater. Yeah. So we are working on all of these areas.
Good, thank you.
Yeah, I'll stop there. Thank you.
Thank you, Ernie.
Thank you.
I was going to say I might have questions later, but we're tight
Yeah.
on time.
Okay, thank you. Sorry.
I've just been informed that we have a 4:15 hard stop, and I want to make sure all of our speakers get an opportunity.
Okay.
So our next speaker will be Leah Laramie. She's the coordinator of State Climate Change Commission. She was previously a natural resource planner with DOFA. Welcome, Leah. Aloha.
Aloha, mahalo, Chair Gabbard and Chair Lowen, co-chairs. Thanks everyone for sticking through this whole time. I have been asked to be quick about this, so let's see what we can do. I know we've heard a lot of negative, realities that we'll all be facing, but Hawaii is really a leader in climate change action. We have a lot of really amazing goals that have been set by the legislature that we are really working hard towards achieving. This graphic is available at climate.hawaii.gov if you guys want to look a little bit closer at it. So I'm sharing in this presentation some of the really amazing, cool things that the state has been doing to address climate change, both mitigation and adaptation. One huge win last legislative session was the legislature allocated $50 million to HDIA for solar plus storage loans for ALICE communities, so that's low to middle income families, so that they can also receive the savings that solar provides, as well as the resilience of solar batteries. We also work really closely with Hawai'i Energy and KIUC to offer rebates for energy efficiency on different appliances, lighting, and other benefits of what am I trying to say? Water saving efficiency and whatnot. So there's some really great programs here that help us with the cost of living in the state. We also have electric vehicle charging station rebate program and the Hawaii electric bike and moped rebate program, which provides $500 with the purchase of new electric bicycles and electric mopeds. These are really great because sometimes it's just a little too far to bike around, but the e-bikes really make it easier, especially when you live up Mauka. We also have the Hawaii Energy Smart for Homes program, which provides free light bulbs and low-flow shower heads. In resilience, the state building energy efficiency transitions and fleet transitions have been really important in making sure that state buildings are being as efficient as possible, and that we're converting our fleets to electric vehicles. We also have established the Carbon Smart Land Management Assistance Program, which provides incentives to do climate smart practices on agricultural land. That includes forestry, ranching, and farming. 21% of our priority watersheds have been protected so far. We set the goal for 30% of the priority watersheds to be protected by 2030, so we're on track to do that and making great progress. DOT has hired a climate resiliency manager. Airports is implementing sea level rise mitigation at Honolulu Airport. There are currently penalties for unauthorized shoreline structures, and sea level rise and erosion disclosures are in place. So as people sell properties, folks are aware of what they're purchasing and what the climate impacts may be. We also are converting our public school bus fleet to electric vehicles through a $5 million EPA grant. Expanding our appliance and equipment standards. This is really important because the more energy efficient we are, the less we really need to rely on increasing our energy production. And energy efficiency is just really, really important in the general scheme of things, as well as updating our energy codes. A huge win for us was banning coal for electricity generation. That happened in 2022. And to supplement that energy, we have multiple solar projects and storage projects that have come online since. And there's also, at the airports, DOT has worked really hard to get airlines to be able to turn off their engines when they're parked at gates while still being able to cool their airplanes so people are not overheating. So a lot of great innovative things that are happening. Also within our Hawaii Sea Level Rise Vulnerability report from 2022, or update, you can see on the right-hand side here, all of these little bubbles show us the progress that we've made since the 2017 report. So there has been progress. There's still a lot to do, but we are moving ever closer to the solutions. In equity, there's an energy equity hui in the state, which is really looking at how we can balance the shift to renewable energies with the high cost of energy as we shift over into reducing fossil fuel usage. There's mapping to identify underserved communities that are going to be at higher risk due to sea level rise and other coastal erosion hazards. We also, the Commission has put together a Climate Social Vulnerability Index. This is identifying different data sets that will really help us to identify who's going to be impacted by climate impacts and who are going to be the most vulnerable to those because they might not have enough resources to respond to those. And also some great workforce development programs such as Good Jobs Hawaii, which was a $35 million grant award for no-cost training and job placement, and the Green Jobs Program, which over the past few years has provided $10 million to provide entry-level job opportunities in green job areas. The Department of Health has done a lot of work in the health sector. They launched their climate and health program, which included a designated person to work on this. There's been a working group put together, a portal. They're doing a study to understand the extent of heat-related illness in Hawaii, and also a statewide vulnerability assessment of climate and health as well. We've also banned mercury-containing fluorescent lamps, which is really important to make sure that mercury doesn't get into our environment. If you want to learn more about all the cool stuff that different departments and counties are doing as well, you can check out our Climate Commission annual report, which outlines, a lot of different specific things that are happening, because that was just a really high-level overview. There's a lot of different things going on, both at the state, county, and community levels. So what's next? Now that we've done these things, what are we going to keep on doing? According to our greenhouse gas inventory, we need to really identify the emissions reductions that are necessary to achieve our 2045 target, which is to be carbon net negative, which is to emit or sequester more carbon than we're emitting. Here you can see where we're at in the latest assessments, which is we still got quite a ways to go. We've gotten some irons in the fire for federal funding requests. DOA is applying for Affordable Clean Energy Grant. I wasn't able to find out how much they're applying for, but I think that's a good chunk that's going to be able to help reduce the costs for producing food by having renewable energy production at agricultural facilities. The state and county are going in as a coalition to apply for $50 million of EPA grant funding for climate pollution reduction activities. So that's a wide swath of things from building retrofits to natural and working lands activities, waste reduction, all those kinds of things that often fall through the cracks for federal funding opportunities. DOT harbors applied for $30 million for retrofits to protect their harbors and make them more resilient to climate change. UHC Grant is leading a coalition of folks to apply for resilient communities through a NOAA grant to look at how to, from Mauka to Makai, to look at climate resilience. And the Hawaii Green Infrastructure Authority is applying for $100 million for additional loan funds to increase the number of rooftop solar available to Alice communities. The Hawaii business as usual model trajectory, even when we look at increasing our renewable portfolio standards, we're set up not to meet our 2030 or 2045 state goals at this point in time. So the Hawaii State Energy Office, through their decarbonization strategy and through Act 238, showed different pathways of how we could actually achieve that, because right now we're not on the path to do so. So some of the things that we're going to keep doing is to increase our focus on equity. The UH is working on an equity mapping tool. We're going to continue investments and focus on energy rebates. There's a lot of federal funding for that, and we want to make sure those get into the hands of the right communities, right people. We want to continue to protect their watersheds and reach our goal of 30% of priority watersheds protected. The state has also pledged to plant, protect, and conserve 100 million trees, and also want to ramp up efforts managing wildfires and invasive species control. All of these actions are, funded through general funds from the legislature. So mahalo to all of you for funding them in the past, and we hope we can continue to get funding in the future so we can carry on those actions. We also have $1.5 million allocated to address urban heat with expanding our tree canopy through community grants, through our Ku'ulunani program. We also are scheduled to have 100% state fleet transition for our smaller vehicles by 2030. We're also, HDOT is working with airlines to convert ground supporting equipment to electric, also working with rental cars to do the same, rental car companies, improving community infrastructure to make EV ownership more feasible, and Department of Education is working on pilot programs in schools to compost food scraps so that we can divert the waste from our trash streams. So what else can we do, and what do we need to do so that we can reach those goals for 2030 and 2045 that the legislature has set? There's so many different components of climate change. I think Chip did a really good job of saying, we're often narrowly focused on this decarbonization, which is a really important piece, but we really need to take a holistic view of all the different things that play into climate change, and that's basically everything that we do. And climate change is going to also impact everything that we do. So, there's a numerous number of things that we could do, but if I was to break it down to my top recommendations, I'd say passing the green fee in whatever form it is in this session, that's going to provide significant funding for DLNR, but also just general resilience. That's going to protect our water supply. That's going to protect our food supply because we need water for food. That's going to start to address sea level rise. And that's also going to help us to look at climate change in a broader capacity. And then the carbon cashback bill. I know that has gone through a few times in past sessions, but this is really an equity piece where we're looking at reducing our demand on fossil fuels by making it more expensive, but also by giving funding back to communities who need it the most. So it's balancing both equity while addressing our need to reduce our reliance on fossil fuels. And then additional recommendations, the decarbonization strategy and the sea level rise vulnerability plan both have great recommendations outlined in them. And if we were to work on these, everything from cesspool conversions to ramping up our efforts to convert to EVs and energy efficiency to planting trees, this kind of has it all. And so if we can fund and implement these recommendations, we'll be a lot closer to reaching our goals.
Okay.
All right, mahalo.
Thank you, Leah. Members, any questions? Okay, thank you. And then we will now have retired Hawaii Supreme Court Justice Michael Wilson, who is the founder of the Global Judicial Institute on the Environment, also a founder of the Climate Crisis Commission of the International Union for the Conservation of Nature, and who's presently teaching a climate emergency law and policy course at UH Law School. Welcome.
Aloha.
Aloha.
And thank you. It's a real pleasure to be here. Thank you, Representative Cochran, and
thank you for your
Lowen
patience.
and Senator Gabbard and Senator Richards. I have to say, one of my kapuna was your dad, Monty, when I was at the Water Commission. And one of the great things we did was to go up and enjoy ourselves at Kahua Ranch. But it's really wonderful to meet you. And I can see your dad. Definitely. Okay, so I've been informed that I have 5 minutes.
No, you can go a little longer than that.
Give us your
Okay.
presentation. It'll be okay if we go.
Yeah, but I think the best thing for my slides is maybe we can just go to my second slide that talks about emergency, because to put a perspective on what I was going to suggest here is where the law meets reality. And in that sense, of course, a lawsuit is a truth testing of policy. And if you were to ask yourself the question whether a citizen has the right to go to court to stop a private actor or a government from hurting them or injuring them, the answer is obvious. So that's happening all over the world. This is the biggest issue facing judges everywhere, climate change, and the effect on particularly, and we have some wonderful young people who are involved in this issue here in the audience, and that's essentially the group that's moving forward, mothers and children all over the world. So what happened in Hawaii? We have a policy history that pertains to mitigation and adaptation that's exciting. We have the father of our environmental court here that was formed in 2014. It's been the most prominent court in the United States on the environment at the trial level. Our Supreme Court is clearly the leader in the entire United States on climate rights. In the state of Hawaii, we have a right to a stable climate capable of supporting human life, which is really important to future generations. We also are the first state that declared an emergency, actually formally declared an emergency. Great policy statements, enlightened, far-reaching. Let's talk about the lawsuits that test the truth of the policy and the actions that are being taken. We have a situation in 2 cases that are testing now the degree to which the policies that have been discussed here and global policies of course, the idea that we're going to protect the planet and future generations are being pursued or not. One is a case, you probably saw the article in the paper, where a group of young people in Hawaii have stepped forward and filed a lawsuit. Not asking for money. They're simply asking for the Department of Transportation to actually put a plan together. We've heard all the challenges they have, but to put a plan together because they have the biggest carbon footprint. You could call it a climate protection plan. And there has been a response that I think is very insightful from members of the legislature. You were asked to allocate $1 million last session for one of the most aggressive law firms in the United States, and clearly one of the most high-priced, a law firm that's been criticized by a federal judge for overcharging. Depositions have recently been conducted where you have the young people being questioned by these attorneys from Los Angeles, and they were so aggressive that the deposition resulted in this young woman breaking down into tears. And now you're being asked to supply $2 million for hourly fees that are in excess of $750 an hour. That is this response of the state of Hawaii when there's a truth testing of whether the policies are being complied with. And the courts so far have said they have a claim. Over and over again, the attorneys have tried to throw it out of court, and it hasn't happened, and now it's going to trial. It's going to go to trial June 24th. So I'm just suggesting that now we're starting to see the reality of whether we're going to be able to address what's the most important issue, obviously, facing the young people in our community. Second lawsuit, very interesting. Maybe the most important lawsuit in the United States, because for the first time, the oil companies, the city and county of Honolulu is taking a different approach than the state. They have moved forward to represent the community. They have moved forward to try to hold accountable those that are causing injury. And it is an extremely, I would say, brave endeavor by the city and county, because they've taken on the most powerful private interest in the world, the oil companies. And this is a case in which the city and county of Honolulu is alleging fraud on the part of the oil companies. Again, there's been an effort to throw the case out of court. It hasn't succeeded. It went to our Supreme Court after I was on the court, and the court said this is a fraud case and it can go to trial. So now citizens of a state where the citizens have seen Lahaina burn to the ground, citizens of the state where they've seen a rain bomb destroy the north shore of Kauai, and citizens that are seeing what's happening to Waikiki are going to be able to sit as jurors. And ultimately, the issue, and I'll conclude with Waikiki, a litmus test or a truth testing of the degree to which we're able to contend with the climate emergency, of course, is this really important resource, Waikiki. There's no plan. It's an amazing thing that there's no plan. I mean, I'm sure there was a plan for rail. It's a big cost item, and there was a plan put together before the RFPs went out. But when it comes to the critical resource of Waikiki, there has not yet been a plan. And I would suggest that's one example that's going to be very pregnant. It's going to be an extremely active area for constant litigation, unless the kind of work that we could depend upon from the University of Hawaii, from Dr. Fletcher, or from Leah Laramie, who is a hero at the Department of Land and Natural Resources, with their expertise, the participation of the community that would be the community of hotels, of course, the private sector, as well as a community that would include the leaders of our financial industry in Hawaii. Anyways, you could put a commission together that would at least address what we're going to do with this really important resource, because it's flooding. You can't hold the ocean back. As Dr. Fletcher said, Waikiki is flooding now, and it's going to become a florid problem. But the issues are profound. Do you open up the Alawai? Do you take down some of the hotels? Do you move some of the hotels? Or do you wait for the hotels to fall into the ocean? The technique that was used in the North Shore, to just wait till the houses start falling into the ocean. So anyways, in terms of the law and where the law meets reality and climate justice, there's a lot of excitement that's taking place now, and I would submit that we can do it. But it's going to take a responsible approach to the idea of respecting the climate rights of future generations and the community. Thank you.
Thank you very much. Members, any questions? Okay, thank you very much. Okay, so now we have two student representatives of the Climate Future Forum. The first is Reina Gamarino. She's a senior at Punahou School, and she's on Zoom. Oh, you're here in person. Hi, how nice. Reina has interned for 5 months with Senator Brian Schatz, and she also founded the Student Advocates for Responsible Technology. Welcome, Reina.
Yeah, I'm Audrey.
Oh, you're
and
Audrey.
I think Reina's
Okay.
on Zoom.
Oh, Audrey's on Zoom. Okay, sorry. Oh, there. All set? Are we all set with Reina on Zoom? There she is. Is that her? There she is. Welcome, Reina. You can go ahead.
Okay, I'll begin. So aloha, everyone. My name is Audrey Lin. I'm 17 years old, and I'm a junior at Iolani School. I am joined by Reina, who is on Zoom, and a senior at Punahou School, and we are both youth leaders of the Climate Future Forum. First, we would like to start off by thanking the Energy and Environment and Agriculture and Environment Committees, as well as Senator Gabbard, for offering us a chance to present our perspective. We would also like to thank some representatives who are not present today, Representative Peruso, Representative Lowen, who is here, and Senator Rhodes for supporting the Climate Future Forum. Finally, we'd like to thank Senator Lee and Representatives Garrett, Martin, and Sayama for participating and supporting CFF. And in addition, I would like to just recognize the words that were just spoken by retired Hawaii Supreme Court Justice Michael Wilson. He mentioned where the law meets reality and the climate rights of future generations, which I think is a perfect segue into our presentation. And with that, I'll pass it to Reina. I think she's on mute.
Reina, I think you're muted.
If we're running behind, I can present if the Zoom doesn't work. Okay. Okay. Do you want me to just present?
Do you want, Reina, do you want to try to maybe disconnect and connect again and see if that works?
Okay.
And check your mic input, yeah. Okay, should we have Audrey go ahead?
Sorry, Reina.
And then we'll come back to you, Reina,
Yeah.
and see if you manage
Keep
to sort
trying.
it out.
Go ahead, Audrey. You can.
Okay, so Reina and I are here to kind of speak on behalf of the rest of the younger generation who see climate change as the most pressing issue facing our planet as we know her. And as we stand here, sea levels are rising, coral reefs are disappearing, ecosystems are shrinking, wildfires are burning, and humanity is being threatened by rising temperatures. So it's up to us. And the question now is, what are we going to do? Well, one thing the Climate Future Forum hopes to do is highlight how climate change is such a multifaceted and intergenerational issue. And only after we recognize such issues can we call for necessary systemic changes. Oh, I think she's on. Hold on. After seeing the need for a medium for productive dialogue between youth, the legislature, and environmental organizations, Reina and I worked with other young people and adults to establish the Climate Future Forum to fill that vacancy. Our work involves wielding political will to drive legislation in various areas. And during our recent December event, we met here in the halls of the Capitol, where we established climate priorities for the upcoming legislative session, turning dialogue into real action. Our priorities included sustainable food systems, as we called for SB 430, and new positions in the DOE and UHCTAHR. We advocate for your support of farm to school, school gardens, and food trees on school campuses. We advocate for farm to food bank programs, the restoration of traditional farming practices, and initiatives that reduce food waste or recover food resources. In addition, in regards to clean energy and transportation, we support solar on all newly constructed homes, zero-emission vehicle purchasing, the establishment of green infrastructure, and the continuous monitoring of hazardous air pollution. And perhaps most importantly, to support just transition, the state should fund climate research, such as in HB 441 or SB 657, that identifies those most vulnerable to the consequences of climate change. And our youth organization emphasizes the passing of the green fee in whatever form to encourage sustainable tourism and the implementation of carbon cashback in 7B 1004 and HB 1146. Which supports the equitable redistribution of resources. And building off of Mr. Fletcher's and Mr. Lau's previous points on investment, carbon cashback helps increase the price of fossil fuels and steer such investors towards clean energy. And our agenda may sound ambitious, but we are a state uniquely situated to spark international change, and our youth are certainly ready. Despite not being able to run for office or even vote in elections, we are, to be frank, not pleased with the current state of affairs that we are set to inherit. And now we want to take action. We see it as our job now to engage in public forums, utilize media as a vehicle for publicity, and create productive dialogue with policymakers to make our legislative priorities known. And as we recover from the Lahaina wildfires, we know classmates who give up their weekends to volunteer on Maui, and those like the Hawaii Youth Climate Coalition who rally to create true change from within the system, or people within our own organization who meet with legislators during their school lunches and write legislative testimony before doing their homework. Today, it is easy to be overwhelmed by the abundance of news articles that discuss the extinction of various species and the global destruction caused by natural disasters, parallel to the political and industry-based resistance to climate-friendly solutions and legislation.
Audrey?
Yeah.
Raina's back on. Do you want her to finish?
Sure.
Okay. Raina? You following along, Raina?
Hello? Anyone hear me?
Yes.
However, venues such as our Climate Future Forum and this very briefing give us hope for the future. There are so many young people ready for systematic change, and I hope that the adults will just pause and listen. Thank you.
Short and sweet. Wow. Thank you guys so much for getting involved. You are our future. And just the fact that you've taken the time to, it's just really heartwarming for us as legislators. And you're already interacting with us and the things that you mentioned. What more can we do to continue this relationship?
I think such opportunities like the one that we've been given today have been a really great step, and also we've met with many of you guys already to discuss our priorities, and now it's just a matter of taking those ideas and putting them into real legislative action.
You got it. Thank you very much. Okay, folks, and with that, we'll wind it down here with, I'll ask Rep. Nicole to give some closing remarks.
I think that the clock is ticking, so just a big thank you to everyone. It was a long afternoon, so thanks for being patient, and appreciate all of the presentations. So much information to take in, and I hope that a lot of people get to see it on YouTube as well.
And for myself, a big hand for all of our presenters. Thank you, guys. Thank you very much. So as was mentioned before, it's going to take all of us. The Kako thing was mentioned a number of times, right? And Laulima, many hands working together. So let's do this, okay? Mahalo.